Good evening, ladies and gentlemen, distinguished guests, fellow engineers, and a very warm welcome to the university students joining us from across the island. We are gathered here today to celebrate a landmark occasion, that is the World Engineering Day 2026. This day is special for two reasons. Around the world, it was declared by UNESCO at its 40th General Conference to recognize the vital role of engineering in sustainable development. Here in Sri Lanka, we celebrate this as National Engineering Day.
Central to this journey is our host, Association of Engineers Sri Lanka. Since its inception in 1906, ISL has stood as the apex body for the profession. For 120 years, it has ensured that Sri Lankan engineers remain at the absolute forefront of the global standards, innovation, and ethical practice. While we celebrate here in Colombo, we join a global community. The 2026 international celebrations are led by UNESCO and the World Federation of Engineers Organizations, in partnership this year with the Institution of Engineers Indonesia. Tonight, we align our vision with the global theme for 2026. Smart engineering for sustainable future through innovation and digitalization. A special welcome goes out to the bright minds joining from engineering faculties across our national and private universities here with us today. You are the architects of the smart engineering we celebrate today. We don't just welcome your presence, we celebrate your potential. You are the bridge between our 120-year ISL legacy and the digitalized future of Sri Lanka in the future. So, ladies and gentlemen, let's have a good round of applause to appreciate the presence of our future leaders, the students from universities.
To formally commence this evening's proceedings, we now invite our esteemed dignitaries to the stage for the lighting of the oil lamp. Engineer Kosala Kambudeniya, the President of IESL, Engineer Prabodha Jinasena, the President-elect IESL, Engineer Grani Jalat, immediate past President of IESL, Engineer Dr. Kamal Laksiri, the past President of IESL, Engineer B.R.O. Fernando, the past President of IESL, Engineer Samantha Gunawardana, the Vice President of IESL, Engineer Mangal Silva, the Vice President of IESL, Engineer M.G. Hemachandra, the Vice President of IESL, Engineer Manjula Samarasinghe, Honorary Treasurer of IESL, Engineer Suran Fernando, Honorary Treasurer of IESL, Engineer Professor Jagat Manatunga, the Dean of Faculty of Engineering, University of Moratuwa, Engineer M.I. Dean, our keynote speaker,
Engineer Neil Abesekara, Chief Executive Officer of Institute of Engineers Sri Lanka, Engineer Harshana Bulatsinhala, Chairman, Agricultural and Plantation Engineering Sectional Committee, Engineer Mohan Vijay Chairman, Building Services Engineering Sectional Committee, Engineer Tissa Liyanage, Chairman, Chemical and Process Engineering Sectional Committee, Engineer B.S. Madhusankar, Chairman, Civil Engineering Sectional Committee, Engineer Viraj Mutugala, Chairman, Electrical, Electronic and Telecommunication Engineering Sectional Committee, Engineer Dr. Madhava Hera, Chairman, IT and Computer Engineering Sectional Committee, Engineer Kamal Vimalratna, Chairman, Mechanical Engineering Sectional Committee, Engineer Rajitha Jayasinghe, Engineer Dr. Narendra De Silva, Engineer Ruwan Nagahawatha, Engineer Jagat Vikramasekara, Engineer Lasit Balasuriya, Chairman, Young Members Section, Engineer Dr. Manjula Siriwardana, and Engineer Mahesh Chaturanga. Over to you, sir, to light the oil lamp. Ayanta Gomez, Dean, Faculty of Engineering, SNIIT Surat.
Thank you, dignitaries. Please be seated.
As engineers contributing to the development of our nation, let's now stand for the national anthem followed by the ISL song, a tribute to the unity and excellence of our fraternity.
Thank you. Please be seated. To officially open tonight's proceedings and to share the IESL's vision for a digitalized future, I may now invite Engineer Kosala Kambudridiriya, the President of IESL, to deliver the welcome address.
Our keynote speaker, Engineer M.I. Dean, Chief Innovative Officer, Sri Lanka Telecom, Professor Manatunga, Dean Faculty of Engineering, University of Moratuwa, immediate past presidents, vice presidents, council members, CEO of IESL, Professor Antha Gomez, Dean Faculty, Dean, and all our presenters, including Dr. Narendra Silva, Dr. Samdena Nakkara, Dr. Manjula Siriwardana, Engineer Ruwan Nagahawatta, Rajitha Jayasinghe, Engineer Jagat Lal, Engineer Mahesh Chaturanga, and all presenters from the universities, all the members, and all the invitees. Very good evening to you. I would like to welcome all of you on behalf of the IESL for the World Engineering Day 2026. If you and I were not here today, not in this world, or engineers are not in this world, how would this world look like? No power engineer, no electrical engineers, no power, no lighting, you have to use candles. But no mechanical engineers to make machines to make candles, so there's no candles as well. So no transportation if there are no mechanical engineers. No aeronautical engineers, no airplanes, no flights, no marine engineers, no ships. No chemical engineers, we won't have any fuel. Anyway, we are running out of fuel these days. So we won't be able to live in this world. But as engineers, are we appreciated by the general public? I think most of you will say no, yes. We are not appreciated. As engineers, we always play a hidden role. We don't contact, face-to-face contact our clients. That's the reason. It's not a unique problem for Sri Lanka. Worldwide, it's like that. Engineering profession is a hidden service. engineers are working behind the screen. They get never appreciated. That is why in 2019, World Federation of Engineering Organizations proposed UNESCO to have World Engineering Day. Based on that request, in 2019, UNESCO declared 4th March as the World Engineering Day. In line with these objectives, I especially thank our Vice President Engineer Mangala Silva and all sectional committee chairs for arranging this event to educate our own engineers as well as general public about the role of engineers today world. This year theme is Smart Engineering for Sustainable Future through Innovation and Digitalization. Why we need a sustainable development? We need development. We need to keep on developing that. But we need to make sure in doing this development, we don't compromise the future generations' requirements for tomorrow. So we need to make sure we protect the environment. We must ensure economic growth, and also we must take care of all social aspects. That is why we need to think about a sustainable development, not just a development. So in doing this one, as engineers, globally and locally, we have challenges. We have a lot of challenges in front of us. As engineers, globally, the technology is changing rapidly at a very, very fast rate. In 2000, certain thing took 5 years to change, but today the same changes happen within 5 days. So in future, that speed will be much short, that speed will be much higher, and all the changes will happen within a short period of time. So as engineers, we must be able to cope up these changes. We must be ready to change. We must be flexible to adapt to those changes. Then climate change. It's not a local issue, it's globally we are facing climate issues, like climate changes. We experienced climate changes in November last year, and even in future it can happen. So we need to make sure our systems and procedures and design, everything are compliant with all these new requirements, climate changes. We can address all these climate changes. Then the world is going through affordable energy, and also we have serious issue. I mean, we have a challenge in education because the landscape of education is changing drastically. So globally, we have those challenges. We need to face these challenges. We need to address these challenges successfully. Locally, the main issue we have today is we don't have engineers in the country. After the COVID, with the economic crisis, most of our colleagues, engineers, left the motherland. So today, government organizations, semi-government organizations, even the private sector is running without required engineers. So we have informed, we have had discussions with the government authorities, we need to address this issue. We need to bring them back. At least we must stop further brain drain. So that's a serious issue we need to address. Without engineers, we won't be able to handle our day-to-day issues and also the sustainable development. Then we are heavily depending on our economy is heavily depending on imports. We are talking about economic growth. I don't think we will be able to have a economic growth unless we shift to an export economy. But to have export economy, we need to be competitive in the market, world market, globally. In doing that, our engineers need to make innovations. They need to be entrepreneurs. Otherwise, they won't be able to add value to the products and services. So we won't be able to compete globally. So if we want to face these changes globally and locally, what we need, what do we need? We must have a mindset to change. We must understand the world is changing. If you are trying to say, we have done this in this way, like අර බාසුන් හැකිනා වගේ අපි අවුරුදු 100කට කලින් 50ක් තිස්සේ මේක තමයි කරගෙන ආවේ ඔයිට වඩා ඔක වෙනස් කරන්න ඕනේ නැහැ. If we are going ahead with that mentality, I don't think as engineers we have future. So we must be flexible to change. We must identify these changes, requirement of changes, and we must come out of this island mentality. And also, we know the AI is making a challenge. So we are very good, we have very good left brain. We are very good in arguments. We are very good in logical arguments. So, but I think we need to start using our right brain as well. If you are not innovative, if you are not creative, I don't think with these changes with AI and all technology, we will have a survival. So I think we need to get out of our bed and we need to start thinking completely differently. Otherwise, we won't be able to face these challenges. So I request all of you to join with us to make this challenge for the prosperity of our profession as well as for the general public. Thank you very much again for participating, taking your time to participate in this event. And also I would like to especially thank Engineer Mangala Silva, Vice President, and also the organizing committee for arranging this marvelous event. Wish you will have a pleasant event today. Thank you.
Thank you very much, Engineer Kosala, the President of Institution of Engineers Sri Lanka, for that inspiring word and setting the note for today's celebrations. Ladies and gentlemen, now we are moving to the key area of this celebration event. To set the intellectual foundation for this evening and explore the frontier of 2026 theme, we are joined a visionary leader in digital transformation as our keynote speaker today. Engineer Irshad Deen began his career at Sri Lanka Telecom in 1991 as an engineer in IT operations and customer service department, where he established the first computerized customer service unit. From 1996, he led key advancements in data communication and internet services, re-architecting SLT's internet network and launching its first ADSL and IPTV services. He later served as the General Manager, IP and Access Network Operations and the General Manager, Enterprise Solutions, and led SLT's Cloud Service Program. Currently, Deputy Chief Digital Officer, he drives digital transformation, enterprise solutions and innovation. He holds BSc Engineering, MSc and MBA degrees and is a chartered engineer and IT professional. With a career dedicated to bridging the gap between traditional infrastructure and next generation connectivity, please join me in welcoming our keynote speaker, Engineer M.I. Deen, Deputy Chief Officer, Innovation at Sri Lanka Telecom.
President of the IESL, Engineer Kosala Kamrudenia, past presidents and of the institution, council members, member of and all member of the IESL, the CEO of the institute, and industry leaders and past presidents and distinguished guests and the students who have been gathered here on this August occasion commemorating the World Engineering Day. So I understand the whole frame of the World Engineering Days on smart engineering and using digital and innovation. So with that theme, I propose this keynote on engineering sustainable services economy. So digitalization, innovation, and AI as catalyst for national development. So basically, I just wanted to bring in my perspective and also the service industry perspective as to how that can be a change agent in being a sustainable service utility in the growing change in the economic paradigm. So if you look at basically the sustainable development goals, so basically there are 17 development goals. So basically, like the engineers have a front and center in most of these SDG initiatives. So, but the new part of it is that how we kind of make the engineering decisions smarter and more intelligent. So that's how we are going to go by. And then, so basically, I think the president recalled about building bridges and engineering building bridges and roads and power plants. But I think like we have to go also to the next landscape of how we kind of evaluate the fiber network, the cloud platform, and the AI model also as infrastructure, where the engineers have to have a big role in the construction of the fiber networks and the cloud platforms and the AI models, which actually drive the value of all the infrastructure we have in Sri Lanka. So the whole idea is that we increase value not through assets but through intelligence. So I would like to take take your attention to some of the engineering fields which we have accomplished in SLT, like in terms of how we are kind of used a sustainable digital ecosystem, like using IoT and AI intelligence to reduce waste, energy, and operational effort. In the fiber to the home FTTH fault prediction, so our engineers have made great strides in actually bringing predictability so that we have 90% accuracy to cut down time, so that if there's like there's a possible fiber cut within 24 hours, we have a 90% chance that we have an ability to signal the first level and the second level so that they can take action, so that we don't need to have truck rolls to serve the customer in the first level and the second level. So that's one part. And then also we have MSAN monitoring IoT, which we have developed at the innovation. And basically we have 8 points of interconnection at the voltage level, at the breaker level at the MSAN. MSAN is where you actually connect up all the broadband lines going up to from the distribution point and from to the OLT to the customer. So basically, this has enabled us to, particularly in high in areas like in Kandy, where the MSANs are in very out of distance. So it's easy for us to do management remotely, because we get visibility from the IoT systems which are plugged into these MSAN systems. So similarly, I think we have also something called industrial IoT sense grid, so which we have actually deployed in the manufacturing establishments at a leading footwear manufacturing company. So we are doing like current level monitoring and things like that. I can't divulge the name of the company. So And also we have like doing a lot of work on AI as well, and we are building like back office automation and AI agents. So basically, like when we look at the digital the landscape, so we have like the fiber network, as I told, the cloud platform and all that. So, but actually, it's actually going to it's a digital nervous system, like, you know, because we have the cloud platform which has all the services and all the hosted services. Then we have the broadband customers. Then we have so much of intelligence which is created over the network. Earlier we just had only like phone connections and then broadband connections, but now the network is getting more intelligent. I mean, you can just understand how the social media, social networks like Facebook and them work, because they are just working on just riding on our network. So I think so it's time that the telcos and also the engineering and the people within the engineering landscape recognize this as a critical national digital infrastructure going forward. And this shift is a shift to the digital infrastructure, which will enable and which will actually enable most of those underlying engineering assets which we have, like the roads and the bridges, and create a nervous system. So if we like kind of decompose it, like we have this how this is set about. So basically we have the fiber and the 4G network, which actually has a like a national backbone, and then we have the from the 5G side we have the RAN, which at the edge of the compute and also the cloud, so which actually gives us the distributed processing across the island. And also what we are actually doing is like we are actually creating an IoT layer, which is an observability layer on top of it, using like protocols like LoRaWAN and NB-IoT, and then what the signals which we get from these is fed into the AI intelligence system, which will give you predictive analytics and automation and decision support. So this is the layer which I'm talking about, which is actually going to help us in this sustainability endeavor and creating smart engineers. So again, I recall most of those projects which I told earlier, the FTTH fault prediction, and these are some of the things which we are actually created on top of this network. Also, I also want to kind of say that about the telecom network. It's a network which is not static, right? I mean, it's a sustainability multiplier, because basically it's a long tail kind of a thing where, you know, like how the social networks percolate from the top to the down. So it'll actually percolate across the nation and across the globe. And it's a sustainability multiplier. So it's actually multiplying the sustenance of all our development goals. So be it remote education, telemedicine, digital government, smart agriculture. So we can actually, if we have any capability in remote education, we can actually bring that economic and the output to the whole of the island. So if we actually take some examples which we have done, so basically we have a program which is an entrepreneurship program within our innovation. So one of the winners was awarded was on mangrove restoration innovation. So he actually designed and implemented a low power WAN architecture for mangrove monitoring and restoration. So this is the kind of environmental kind of projects which we have actually dealt with and which we actually cooperating with entrepreneurs to go and integrate with them and go to the market. So what we want to do is like, make this our whole, our value system, our digital nervous system as an enabler for anybody to come and, develop these kind of things which are actually for the smart and the sustainable industries. Another thing which we have developed is this Smart Agro project, Fazenda project, which is actually giving observability, and it's actually a pole-mounted sensor-based system where we actually detect all the KPN levels and the water levels and all the measuring instrumentation which is necessary at the agriculture level, which is actually we typically kind of put it at each level in the farm, and from that we are actually monitoring and giving advisory to improve productivity. So this is another sustainability multiplier. Another one which actually came and which actually made a big impact to us during the COVID time was this eCPHALA education platform, where the masters, because obviously the students was not able to go to our school and all that, so we actually created this educational remote education platform, which created a multiplier effect across the country, and also now it's actually a commercial option where any person, who wants to create some kind of a education institute remotely can actually acquire these assets from us, so that we can host it on the cloud and give it to them. So from that, I actually come back into an important concept of considering AI as an engineering control layer. So basically, so gone are the days where we have, I think, SCADA and things like PID controlling is necessary. But I mean, what's happening is like we are now moving more on to AI optimization and also on the digital feedback loop. So on top of the SCADA and all these things, PID controller, we have an observer detect the system, anomaly detection system, the predictive algorithm degradation system, and also an autonomous system where it can self-correct itself. So you are coming into a situation where we are creating kind of a control system where you bring in observation, prediction, detection, and also enforcement, orchestration. So I think AI is part and front and center in this, creating this engineering control layer. So as I had informed earlier, so these are the things which actually it controls. So continuous monitoring system behavior, detects anomalies and predicts degradation in patterns, optimizes resource allocation, guides human decision making with data-driven insights. So basically AI transforms infrastructure from static connectivity into an intelligent, adaptive, and digital ecosystem. So I think the systems we have, the power systems which we have, like whatever, like, we can actually create a control layer where we can actually be more predictable and of outages and all that stuff. So this is how the industry is going forward. And AI with EST is the path to net zero. So basically, in Sri Lanka Telecom, we have like 3 data centers, and also we have now investing in some more data centers. So basically, we are conscious about the power usage and power monitoring. So that's one part of it. And then this also comes into the whole gamut of sustainability. So we have like carbon tracking and ESG tracking and sustainability analytics. which is all connected into that whole the monitoring system which controls all the data centers, all 3 data centers island-wide, and which is seamless so that we can kind of connect as many data centers as you want. So basically, it helps reduce net zero by turning sustainability into an optimization problem. Reduce energy through intelligence monitoring. So we can reduce energy with intelligence monitoring. We can cut waste and field operations. Track carbon efficiency metrics and using analytics and reporting. So AI makes ESG measurable, manageable, and continuous improvable. So this is the power of AI. So AI, in a controllable and a more responsible manner, can actually give a lot of insights and input to the industry. So this, from a sustainability perspective, I actually looked at a service architecture. I think I discussed most of these things like infrastructure, intelligence, sustainability. So basically, this is like a layered approach, an architectural framework, where we have at the bottom layer, we have the digital infrastructure. So that's where you have the physical and the cyber infrastructure together. So that's like you have the instrumentation which actually abstracts the data of the physical infrastructure. So that's the digital infrastructure. Then on top of that, we have the data and observability. So basically, we have we get all this data and then we create a data layer using things like, if people know this, things like Kafka and all that, where we can kind of get all this telemetry and observability. And then on top of that, we have the intelligence where we run all the AI models and all that. And these actually, in this situation, we can actually gather this, summarize this into sustainable outcomes, which actually would pivot to understanding how sustainable your project is or whatever, and then actually we can give key metrics out of these things. So this is actually the whole architectural perspective of what I consider sustainable service industry architecture. So as I said, this is how it is. So the layer 1 will have the digital infrastructure, the fiber, 4G and all that. And layer 2 will have the data observability, IoT, telemetry, network analytics, operational visibility. Layer 3 will have the prediction, automation, optimization, decision support. And layer 4 will be the sustainable outcome with high efficiency, reduced resource consumption, improved resilience, revenue growth, so on and so forth. So this is, as I envision, this is the opportunity we have actually. So as I understand, there's ICTA is drawn down an approach of Digicon. So Digicon is Sri Lanka's digital landscape from 2023 to 2030. So basically, this would create the digital layer, but I think the engineers would have a bigger role in this, because how we kind of align all the agencies which we actually have control over, like the transportation, the roads, and the civil, and all the power systems and all, and if you look at all that. That engineering fraternity is with the IESL. So that knowledge is with the IESL, which we can create in this sustainable value layer, which I told, which we can merge with the ICTA in terms of actually bringing digital service and a digital industry future. So that is something which I envision. So, I mean, that's how we take it. And then basically, we can actually, if we can like build this digital twin, we can actually be a basis to actually export this digital innovation regionally. So I think if we take a leapfrog on this, so Sri Lanka has a big role to play, and also the engineers also have a monumental role to play. So that's what I said. So it's a leapfrog to legacy systems. So basically adopt AI, cloud, and IoT without being constrained by outdated infrastructure, build a digital service economy, transform telecom, enterprise, agriculture, and public service through intelligent platforms, and export digital innovation regionally, scale locally developed AI and IoT solution to regional markets. So we have actually a great opportunity to take this forward. And so just a bit on responsible AI. So basically, responsible AI is also a big part of this. I think we have to be very conscious about how responsible we are with the data and the AI, because there's a lot of things happening in terms of AI, privacy and transparency, and how it will actually affect the environment. And if it goes the wrong way, the accountability to the environment will also be affected. So we'll have to have like ethical AI frameworks, ensure fairness, accountability, and human oversight. Every time there has to be a human oversight, either human in the loop or human on the loop. And data privacy, I think the government has taken a lot of legislation and on data privacy. So protecting user data is also very critical, and making it maintainable, user data, and maintain clear, explainable decision making is very important. And accountability, environmental accountability monitoring, performance and usage to minimize environmental impact. So responsible innovation ensures AI strengthens trust, security, and sustainability across digital infrastructure. So basically, this is a message on ethical AI frameworks. So at the end of the thing, I think I have proposed a value transformation, like it's a value engineering cycle where actually how engineers can be a part of this value transformation. So basically, we are like building all this agriculture and health infrastructure and all that, but how to make those smart? So making those smart, there's a big part of engineering. So that's called value engineering. So at the front and center, in the middle of it is AI and data. So AI and data will be a critical enabler in this value engineering part. So I think engineers would have a role in all these areas. So I think basically skill transformation also has to happen in these. So basically, otherwise, as engineers, we will be left behind. So I think it's also about physical and it's about digital as well now. So basically, like we have this physical layer and then the connectivity layer connecting all the at the IP layer, and then we have the observability layer. So basically, at each of these components, the engineers have a critical role to play. So I think I come to the end of this thing, but I'll actually just wanted to give a statement before that. And I think the statement goes on this World Engineering Day to 2026. Let us commit not just to building systems, but to engineering sustainable digital futures for Sri Lanka. Thank you.
Thank you very much, Engineer Dean, for that enlightening address aligned with today's theme, innovation and digitalization. Ladies and gentlemen, shall we give our keynote speaker another big round of applause? World Engineering Day reminds us that innovation is not confined to one discipline. It grows and succeeds when we work together. We now proceed to the first set of technical presentations by the sectional committees. First, let me invite Engineer Rajitha Jayasinghe from the Civil Engineering Sectional Committee to deliver his presentation on drone-based digital photogrammetry for structural assessment and corrosion evaluation of telecommunicating towers. Engineer Rajitha, the stage is yours.
Good evening, everyone. It's wonderful to be here today celebrating the World's Engineers Day. And it's really good to see that very houseful kind of crowd today at IESL. So I think it's very timely and a very related topic that we are here discussing, the sustainable future through smart engineering, and especially focusing on innovation and digitalization. So today, in next few minutes, I will be taking you through practical understanding we could gather through a project we were recently engaged. In this, I will be talking about drone-based digital photogrammetry for structural assessments and corrosion evaluation. Here we will be talking about towers, but this concept or this technology can be used in many infrastructures like bridges, high-rise buildings, factory setups and everything. So moving on to the topic, why we need tower surveys is that our main requirement when we are trying to do a tower survey is to understand the current loading capacities and whether they are adequately strengthened in order to for us to add new components like antennas or accessories, and also to understand the durability of the towers as a whole. So current practice is actually we are solely relying on manual measurements or manual rigging. So this process is called rigging. Climbers go up to the towers, taking measurements manually, taking photographs or measuring using digital vernier calipers or the tapes and everything. And this process is very cumbersome and very risky, you know, because some towers, they are about 100 meters, 150 meters tall. And when you go up in the towers, sometimes the mist or the bad weather condition is, if it is faced, so it's really hard for you to conduct these engineering measurements in a safe manner. So we thought of, when we got this project, we thought of like how we can look at this thing differently. Then with our experience in the drone usage, we thought, okay, we will use photogrammetry and try to develop tower models using this technology. So what we do here is that we are using specialized drones, not just the drones, you know, we are using for the videography and, you know, recreational stuff. We use very high accuracy drones that are fitted with real-time kinematic GPS sensors, and that has like very high cameras, about 45 megapixel cameras, and also with LiDAR technology. So what we do is we basically pre-survey these towers. Then we create specialized tower scanning flight routes, and we do the modeling. So just to explain the process a little detail, we do the pre-flight sessions using specialized drones, and here we are using this special gadget called Manifold, which is an onboard computer. So unlike, now most of the time when we are talking about image processing, we used to do these things in workstations. But the technology now is so advanced that we can have mini computer units on the drone itself that can process the images real time. So what they do is they basically get a rough sketch of the tower as they fly, and they create the basic shape of the tower. Then we use that basic shape and we do rigorous flight planning, keeping very precise flight angles, the camera angles, flight spacing, and the distance from the tower. So why this is required? Because then only we will be gathering images that are very accurate and very high resolution in order for us to create a good quality 3D model. So by doing this process, then we get the images, then we create the 3D models that are very high resolution. Those are not just, very fancy kind of nice looking models. Those are measurable, pixel to pixel, these things are measurable. So then we take measurements from the model, and obviously we can't take all the measurements from the model itself. So we have to incorporate a little bit of manual measurements also. But the thing here, the innovative edge is that we are reducing the manual labor drastically. So then this is how the flying patterns look when you are using these things. So this is the thing I've been explaining. So once we fly in this way, I mean, it is impossible. Just imagine having a 150-meter tower and trying to manually fly around this thing. So it's impossible. So this is why we need technology and adaptation. So once we create this, then we have all the information that we require. Then again, can we solely depend on this thing? In our experience, it is not. So what we do is, we take these measurements, we incorporate, and we understand where are the vulnerable points, which parts are not clearly visible in the model. Then we use our manual rigging process to cover those areas. Then we get all these details, and we can create the general arrangement of the tower. So when you get the general arrangement, we can do structural analysis very easily. And in next slide, I will show. So this is a tower model we have created. So this is kind of globally, but this sort of a tower is about, when fully modeled, it comes to about 70 gigabytes. And like I said, all these components are measurable. So you can go up to millimeter levels if it is required. So whenever you are doing a structural analysis and having this sort of a model, it clears most of the ambiguities you have. So you are having the exact idea what this tower, where are these what are these components, how the legs are loaded in which angles, and when it comes to antennas, we can think of we can get azimuth, tilt, all these things, and also we can get high resolution images, and we can understand the severity of the corrosion and how badly it has been spread. So if there are very vulnerable members, we can advise our riggers, the manual, the process can be optimized in a way to mitigate the risk. So by this whole process, this is where we are landing. So this is the line diagram or the general arrangement of a tower. So once we have this, we can use ABS tower or SAP, and then we can go into processing. So talking about the innovation part or the process efficiency. So in our case, we could map 11 towers in 12 days. So we, with our past experience, we understood it is about 30% to 40% time saving, and again 25 to 30% of cost saving. And above everything, we are now getting very good measurements that are accurate and full or real picture of the towers. So our experience, we can use this concept or we can use this technology for several other infrastructure as well, like bridges, the steel structures, the factories, or even entire buildings itself. We can use this, and I mean, we are here thankful to IESL, and we would like to make a very open invitation to all the students present here. If you are thinking of doing any kind of research or any undergraduate research or any collaborative work, we can support you to move into these segments, because our next step is to understand how this process, I mean, we can get the models now, but again, the drawing part, massively we are doing manually. We are trying to go into AI modeling of these components. So if you are interested, we are very happy to support you and jointly develop research and go into R&D also. Because the way I see the smart future or smart sustainable future can be only created through collaborations. So we have to come together, we have to share our knowledge, share our assets, the capacities, capabilities, and then only we will march towards a sustainable future. And thank you very much for IESL and the committee and inviting us for this event. And I would like to make a very special thank and acknowledgement to the project, the Digital Terrestrial TV Broadcasting Project, the project director and the PMU, and especially the contractor, the Yachio Engineering Japan team. So they have been very helpful in this entire project, and they very warmly welcomed our idea. And to be honest, this kind of new technology for the structural engineering has never been used before for the tower segments. I mean, I'm not talking about just sending a drone and taking some photographs. I'm talking about creating engineering grade, millimeter level accurate models and going into structural analysis. So thank you very much, and wish you all the best. Have a nice evening.
Thank you very much, Engineer Rajitha, for that innovative and detailed presentation. With that, ladies and gentlemen, let's move to our second presentation. Representing the Electrical, Electronic and Telecommunication Engineering Sectional Committee, I kindly invite Engineer Dr. Narendra De Silva to deliver the presentation on smart electricity utilities for sustainable future through innovation and digitalization.
Good afternoon to everybody. I consider this as a great opportunity to present the envisaged future of the power sector. The engineering in the world was developed through 4 revolutions. First engineering revolution, second, third, and fourth. The most important thing about these revolutions is that once when this revolution is going through, people who were before the revolution can never think and can never imagine what is going to come after the revolution. For an example, the first revolution, which introduced mechanization and water power and steam power. Before this revolution, the steamships, steam engines, nothing was there. People never imagined that after this revolution, their lives and the way of doing things would change up to that level. Same with the second revolution. where the electricity came in 1900s. 1800s, the first revolution. Electricity brought the second revolution, 1900s, and came the third revolution, the computers. Before the computers and after the computers, our way of life was entirely changed. Now we are through the fourth revolution. And we will never, and we will not be able to imagine what's going to be our lives after the fourth revolution. So once when we are going through this revolution, entire world is changing simultaneously, embracing the revolution. We have to ask from our sides, and we are asking that question, how power sector should embrace this revolution. What I'm going to present here is kind of a marginal glimpse on as to how that we are going to embrace this revolution. So we call this Industrial 4, and together with that, Utility 4. So the old utility model is reactive. We react on something. The Industrial 4 utility model is data-driven. Our decision making, everything would be data-driven. This is the basic, fundamental of the idea. In a bottom line, how exactly we are going to do with 3 steps. First thing, modeling. As we know, control engineers. Everybody who has done controls can remember their school, university days. What we do, in controls, we model and we create a reference and we control. In Utility 4 model also, exactly what we are going to do is that, but in a very high macroscopic manner. We model the power system. We model our utilities, utility management structures. Even we go into modeling individual humans and our population. We call that the digital twin. The name that we use is digital twin. Ceylon Electricity Board will have a digital twin. When something happens on the physical electricity board, in the digital twin also the same transformation is going to take place. So we can keep aside our physical utility and look into the digital utility and take decisions, make changes, and do experiments on the digital utility to see exactly what will happen on our physical utility. Power system planning, network restructuring, everything. Not only engineering, but even down to finance, human resource, everything. Twin is absolutely same as the physical utility. Then comes the referencing. These digital twins created across the country, across the globe, will have references. They'll be talking to each other. They're comparing. What we do today called benchmarking will convert into digital referencing. Then the third thing, the controls. These feedbacks will start creating controls. On the digital twin and the physical twin, the new controls will start coming, autonomous controls. So we'll go step by step into this, exactly what's going to happen. The concept of the digital twin. Digital twin will be created by 3 layers: field devices, data centers, and the utility management centers. Field devices and the data centers will be integrated through wide area network. Across the country, large network. That's mostly the mobile network or some other physical network. Then the data center and the utility management center, where all the engineers, everybody is sitting, will have a interface, the office network. In the field, there will be cluster of measurement devices, smart meters, smart switches, the transform monitoring units, network monitoring units, myriad of cluster of digital equipment. On the data center, there will be an Internet of Things net platform, which is integrating these digital devices, API platforms, enabling communication, scheduling and orchestrating platforms, doing various scheduling work, and business analytics platforms, carrying out business analytics, asking various questions and creating answers, which create the data center. Finally, the utility management center will have the ERP, enterprise resource management systems, HRIS, human resource information systems, UBS, utility billing systems, ADMS, advanced distribution management systems, GIS, and planning software. The entire cluster of software, what we call today the IT, will be housed in this management layer. So this is how the digital twin is going to be built. So once when you get everything together, what you are creating is an imprint of your organization. Your network, your human resource, your finance, everything will be, you're creating another imprint of the utility. This is called the digital twin. I'm elaborating the process of Network 4 or the Industry 4. Nobody knows what is Industry 4 actually. Neither myself who's talking here, nor any of us know until the Industry 4 happens. So all what we can say is we can have kind of an idea what's going to happen. This is our very primitive way of understanding what's going to happen. It might be entirely different thing. Imagine before the steam engine, an engineer standing here and talking about steam engine. Something like this is going to happen, and you know the rotating things will come and etc. So I'm doing absolutely the same. Probably the steam engine will be entirely different to that guy's thinking. So the way of operating Industry 4 is that old way, the quarterly or yearly KPIs compared across industry. Industry for machines, processes and supply chain and real-time data envisage. The real-time comparison of cross-sector utilities, operations and exact presence. We have an interesting term for this, what we call single source of truth. It's called single source of truth. We in all organizations can, if we ask the question, do we know the truth of the organization? We don't know. If somebody asks me what is the number of customers in LECO, I don't know. Because today its number is today morning it was something, today afternoon it's another thing. New connections are given. Disconnections are happening. People are applying for disconnections. So my customer number today morning and today afternoon is different. It's continuously changing. But if you ask me that question, I very boldly tell you some number, which is entirely wrong. At the very moment that I am telling you that, I know that it's wrong. So the knowledge that we have of our organizations is that it's not the truth. It's an imprint of truth, or it's a lie. Everything we talk about our organizations is absolutely lies. Big lies or small lies. So, because we don't know. Because why? The single source of truth is not there. In my company, customer number is there in multiple places in multiple numbers. If you ask me, I say 684,000 is my customer number. That's the general manager's number. If you go to operations manager, he has another number. If you go to DGM, they have another numbers. Everywhere this number is different. We morning to afternoon struggle to make this numbers come closer together. And all of us know how well that we are doing it. So the Industrial 4 talks about a thing called single source of truth. There's only one truth. So that's the concept of Industrial 4. If we are to look at the development, no digital data by manual entry, near real-time manual entry, and the real-time automated. That's the growth of data creation. And together with decision making, manual based on intuition, intuitive decision making. Then goes manual based on data. Then goes partly automated and automated. So once when data is available, you see it is diagonally expanding. When you start getting more and more data, decisions become data-based. So Industrial 4, look at having perfect data and automated decision making. That's where we are moving in. Probably we may be in somewhere 1, 2, 3 area. We'll be head and paper business. Our utility management is at the moment head and paper, or probably spreadsheets. So we are moving into ERPs, partial digital decision making, and finally coming into the automated decisions. Then grids will decide, the grid automation will decide how to switch, how to re-switch once when a fault occurs. So similarly, most of the internal decisions will also be made digitally. So what's the course of development? Digitize the assets. There's interest in two terms, digitization and digitalization. Digitization is creating digital data. Digitalization is the part that we are talking about, the software and all that. Digitize assets, connect systems, collect and store data. So these three most likely we are doing it. Probably we may be in somewhere number 3. Apply analytics and AI, automated decisions, build digital twin, and finally the cybersecurity. So that's the course of development. So the power sector, our utilities will go through this process. Faster you go, stronger you will be, and resilient you will be, and compatible with the rest of the nation and the rest of the world. Thank you very much.
Thank you very much, Dr. Narendra De Silva, for your inspiring presentation. Next, I would like to invite Engineer R.T. Nagahavatta from the Mechanical Engineering Sectional Committee to deliver his presentation on how green transport can be the catalyst in renewable energy integration in Sri Lanka.
Thank you. Good evening, everyone. So today my topic is how we can use transport as a catalyst in renewable energy integration into our national system. So engineers' commitment. So generally we have to see in our institution, we had inbuilt under Code of Ethics, Clause 3, right? How we should work in our industry. So engineers shall be committed to the needs for sustainable management of planet resources and seek to minimize adverse environmental impacts of their engineering works, right? So it is very important for us to see that we create this environment where more renewable energy would be accommodated into our system, and how we can use it for benefits of public and all the countries current economic situation. So we had put this one on clause 3. We had put only 2 clauses about that one. One is the public safety and the accountability of engineers to the public, and the second thing is our dignity and honor of our profession, right? So apart, as a third clause, we had put this one. This is very important to us. So we have to make sure that all our endeavors should committed in sustainable manner. So if you go by the current power demand and the power generation curve, you can see here. Yeah. So you can see the yellow patch where the solar is coming from the morning, and it is spreading up to almost 5 o'clock, right? So without developing our industries and our power usage sector, we will not be able to increase, the height of this demand curve. So that would be a biggest challenge we would be facing. So we have to build our supply chain, we have to build our infrastructure to make more manufacturing friendly country where we can improve our energy demand curve to absorb more renewable energy. But we don't see with China's development on, being a world factory, right? So we will have much opportunity to compete with them. So we have to see how we can widen this one, where we can see more utilization of renewable energy during morning and evening peaks, where we can support more renewable energy integration. So you can see this is the actually from Ceylon Electricity Board, how they are predicting our energy utilization curve will change and how our renewable energy potential for 2050. So you can see like after 2030, we will be having larger contribution from solar energy and wind energy. So our coal and fossil fuel based energy systems will be diminishing, right? So that is the future. So, but we have to see at current context how we can support more integration of renewable energy into our system. So if you see, this is the timeline distribution during a day, how the Sri Lankan transport sector varies, right? So the public transport and the the private vehicle, they will start from early morning, and so generally the peak will happen from 6:30 to 8:30. But it will spread for a long period, but the peak will be happening at that time. So where a lot of fossil fuel burning will happen during that time. And also in the evening, you can see from 4:30 to 6:30, we will have another big peak where the fossil fuel would be using. So if we can see opportunity, how we can support this sector with the renewable energy, we can go for more renewable integration into the system. So if you see, this is the country-wise, on province-wise, how much public bus fleet is operating. So you can see how many kilometers they were, passenger kilometers, almost 19 million. So operated kilometers, 19 billion, so almost 425 million kilometers being traveled for a year using bus, our public transport. Similarly, you can see how much fuel we are using, fuel consumption. From 2011 to 2022, so the utilization of our economic reserve for buying fossil fuel. So can we go into electric vehicles and electric locomotives where we can go into more electricity demand in our transport, where we could create more demand in the morning and evening peaks, where the renewable energy could be accommodated into the system. So this is the whole theme behind this one. So if you see, we can bring additional power demand by public transport. So if you take first one, our locomotives or the trains, right? You can see electric train. So generally electric train will consume 0.05 kilowatt hour per ton per kilometer, right? While diesel electric locomotives generally use 0.11 kilowatt hours per tons per kilometer, right? So if we power this requirement through renewable energy, we will be able to reduce a lot of our energy, fossil fuel requirement required for the country through the renewable energy sources. So similarly, the electric vehicles. So you can see the public bus. If you use public bus, you can see average 12-meter city bus would be using 1.1 to 1.3 kilowatt hours per kilometer. So in idle situation, so high consumption, heavy traffic, it would be like that. So the minibus would be using on this one. So you can see this is much cheaper compared to the current fossil fuel usage. So if we can integrate this system into the our energy model, where we can see more opportunities for renewable energy to infiltrate into the national grid. Similarly, the electric vehicles, the private cars, you can see they are generally, the norm is you can run 100 kilometers with almost 15.5 kilowatt hour, right? So with these three factors, generally the railway and public buses and the vehicles, I'm trying to equate a system. You can see daily in Colombo city alone, we will get around 250,000 private vehicles. So if you take average of 50 kilometer range, you would be requiring additional 2,500 megawatt hours. That's 2.5 gigawatt hours per day. Right? Same way, if you take 10 wagon electric train, so generally, which will run for, right now our train network will be operating around 17,209 kilometers per day. So if you calculate the 10 wagon electric train operating that one, it would be contributing 430 megawatt hours additional demand for the country. Same way, the buses, right? So our bus fleet is the biggest fleet, right? If we can electrify that one, you would be generating additional more power demand of 1.5 gigawatt hours per day, right? So totally, this would add another 5 gigawatt hours per day for us in the national grid, where we could infiltrate, we can fill the gap through renewable energy. Current, as we all know, our industries are not picking up that fast because we don't have very reliable supply chains. We don't have good infrastructure. So we all have to depend on China and other things. I don't see much industry development in our country where we would be more focusing on consumer economy, right? So there we have to see how consumer economy would be convert into more renewable energy usage. So this is one example where we can see we could generate additional 5 gigawatt hours for the national grid, where we can infiltrate with that one. But I will be failing in my duty if I don't tell the challenges of electrical engineering giving this additional energy, right? So challenges in renewable energy integration. So basically, most of the renewable energies are intermittent, right? So I will show you how it's behaves. So and the other thing is renewable energy could not create ramp rate. So sometime you saw our peak demand was like 6:30 p.m. to 6:30 a.m. to 8:30. So with that one, you will be demanding very high energy requirement through national grid, where sometime your national grid current power plant would not be able to ramp up the power generation during that cycle, right? So that is the second point I'm making. And the other thing is battery storage system. Everybody talking about battery storage system. Generally, battery storage system operate with 0.5C and 1C, which tells us it's like if you have 500 megawatt hour battery storage, it would take in 0.5C curve, it would take 2 hours to deliver the energy stored in the system. So if you divide it by number of minutes, you can see it's about 4 megawatts per minute. So our demand would be much higher than that. So that would be the challenges we are having even with battery storage. And the other one is unpredictability of climate change, right? So currently we all know how climate is behaving. It's very, very unpredictable nature where we find it doesn't match every year even, right? So very, very difficult to plan based on previous year data. So as an electricity board or the utility company, it's very, very difficult to see how the renewable integration could support them. Final factor would be the high capital investment that the national grid require in integration, right? So if you take here, you can see this is a domestic solar generation system. You can see how power had decreased within a very short period, right? If you take power in y-axis and the time in x-axis, dP over dt is almost like infinity in some cases, right? So this kind of power demand could not be very easily matched, right? Similarly, you can see the bigger, so the solar and the wind, right? So you can see the wind and solar. Similarly, they are behaving very intermittent and very fast changing pattern, right? So it is, as engineers, our duty is to see how we can rectify this one, right? So it is not that we are complaining that renewable energy is having these problems. We have to see how we can support that one, right? So as a country, we have to see, we have to have first develop comprehensive transport master plan and sustainable urban mobility plan. So basically we have to see where we are going to use electric buses, where we are going to use electric coaches, and this plan has to be developed properly. And the second point would be electrify the public and private vehicle fleet. So it's very easy to electrify the public vehicle fleet because you will all know the utility factor of private vehicle. Generally, if you have a car, it won't be used for more than 2-3 hours in a day. But if you take a private public bus, right, how many hours you will be using? Almost 22 hours you will be using that one. You hardly have enough time to charge it, right? So that is the challenges we have in the system. So so in that one we have to see which sector, which area we can electrify the public transport. Third one would be investing mass transit system, electric buses, charging infrastructure. So, Makumbura, Kandy and all these systems, we have to see how we can generate, electric buses, charging station and all these systems where we could support more electric integration into the public transport system. Fourth point would be creating financial tool in banking system to transport sustainable transport transition, right? So currently, we all know electric vehicles are very expensive, right? So if you have proper financial system, there will be more tendency for people to go into the electric system and create more demand during peak hours. And fifth point would be introducing incentives for electric 2- and 3-wheelers. We all know how many 3-wheelers were running in the country, right? How much we can contribute through that one. And finally, the sixth point would be invest in reliable weather monitoring system. This is actually most demanding requirement of Ceylon Electricity Board because our weather system is not predictable. It is very difficult for Ceylon Electricity Board, even anybody, to predict tomorrow how the solar generation would be, how much the wind generation would be. So it is very important for us to have very precise weather monitoring system. You saw in Ditwa, right? How people were reacting to weather messages. We neglect weather messages because it had proven false alarm many times of the year, right? We are blaming people, you didn't move, but out of 100, 98 times they are false reading, right? So when you get 2 readings, you are blaming everybody, right? So that is the system. We have to make sure our weather monitoring system are predictable and accurate, and they are with the latest tools where we can predict our system so that we can see what would be the integration. Because if we fail to deliver the renewable energy within time, we have to get next available fossil fuel system, right? So I was telling, right, it's like battery system, you can generate about 2 megawatts per minute, right? So that would be the, injection speed, right? But when you take gas turbine, gas turbine, they can inject 20 megawatts per minute, right? So if it is in open cycle, if it is in combined cycle, you can go by 13 megawatts per minute, right? So you can see how fast they can inject power into the system and make the utility more, stable in such manner. Final factor would be make faster, reliable, and accessible public transport system, negate use of private transport. Because right now, we all know public transport is not at our convenience. We have to drive and you don't have place to park and all these problems are there. So if we create our public transport more attractive, more reliable, more convenient for us, we would be, I'm sure our public would be using it more, preferably than their private vehicles. So it is our engineering duty. I think as engineers, we have to see this one. We can't complain people, okay, you are not using electric vehicle, but you have to create this environment to make this system work. So it is not a single action. We have to see series of action, how we can support this one. I think with that one, we will be able to add more renewable energy into the system where we can reduce the costs and, reduce the dependability of the fossil fuel system. Thank you.
Thank you very much, Engineer Nagavatta, for that insightful presentation. Ladies and gentlemen, with that, we are moving to the 4th presentation of the day, the 4th technical presentation. Representing the Building Services Engineering Sectional Committee, I kindly invite Engineer Jagat Lal Vikramasekara on stage to deliver the presentation on energy efficient buildings, the backbone of a resilient and digitally enabled Sri Lanka.
Thank you very much. Good evening. Good evening. So the topic given to me today is on the way. Energy efficient buildings. We are from Building Services Sectional Committee. So backbone of a resilient and digital enabled Sri Lanka. So I will pick 3 words out of this particular topic first. That digitally enabled, I hope number of presenters, especially starting the keynote speaker, highlighted numerous aspects of the word digital. Digital and digitizing. I hope you already know the difference of these 2 words. And the resilient. Why the word resilient came in? Sri Lanka has gone through numerous difficulties. Recently, we had Ditwa. Before that, there was another thing. Before that, there was another thing. So Sri Lanka is going through a lot of changes in a short period of time. So we need resilient system. Based on that, let me discuss about building efficiency. We are in an era where the energy prices are going higher and higher every day. Now we have a new topic. Few days back, we have another challenge. It is not happening in Sri Lanka, but effects are already there on the road. So the energy prices are affecting numerous ways. Then the grid instability and peak demand challenges. I don't want to highlight. Numerous speakers highlighted this point. The current generation and the demands are not matching with each other. One side is always going up, one side is always going down. As a result, power system is not stable. Next thing is the most interesting one. Third item. We are in an era where data consumption has gone up drastically. We rely on data. We need more data. We always do our day-to-day works via your mobile phone or certain apps. That part of our life. In order to provide these services, we need numerous data infrastructure, which include servers, switches, data centers, and one gentleman also highlighted fiber infrastructure, which would be going along our roads. These are needed. Next thing is ESG pressure. ESG stands for environment, social, and governance. These factors, these elements are also pressing us to go ahead with efficient buildings. Due to new government rules, we have to put up certain set points, certain norms before putting up our building. Especially when it comes to data, all the data are residing as pulse of an electricity, which means we need electricity in order to run these things. Again, it is putting some additional stress to national grid, national utility suppliers. That's why when we talk about smart cities, when we talk about digital transformation initiatives, efficiency has come as number one point that we have to discuss again and again. Ladies and gentlemen, that is why energy efficiency is not optional. It's going to be economic protection. If you are not efficient, our economy will collapse once again. Why building matters in Sri Lanka? On global perspectives, 30 to 40% of global energy consumption is due to buildings. It's a massive volume. If our buildings are not efficient, if our buildings are not consuming energy productively, outcome will be catastrophic. We are wasting a lot. Next thing, we do see a lot of buildings are coming in. In Sri Lanka, you would see hotels. We expect a lot of tourists who would come into the country. We need a lot of hospitals due to the growth of the immense population. Apartments. That has a greater impact to our economy as well. Government is always pressuring onto the construction industry. If we get power shortages frequently, that is definitely affecting to our GDP. That is affecting to our hotel industry. So that's why, ladies and gentlemen, we have to keep each and every building that we are putting up more energy efficient. It is not a luxury anymore. It's a national survival strategy. And let me highlight what is energy efficiency in modern terms. Few years back, if somebody wanted to improve the efficiency of a building, we simply suggested, let's change the LED lamp. All the incandescent lamp, we remove them and let's install a couple of LED lamps. We will change the chiller to a maybe magnetic bearing or something like that. But that era has changed now. We have to use modern technical tools such as IoT-based monitoring, artificial intelligence-based analysis, and few of presenters also highlighted topics like digital twinning. When it comes to a modern building, we have to monitor everything. We must know what we are breathing. We must know how much light level that we are getting exposed to. So digital monitoring plays a bigger role. And once again, when you talk about efficiency, you would say, okay, let's install number of efficient devices. Of course, it has to be there. The devices, lighting sources, chillers, air conditioner that we are using has to be energy efficient. But just imagine a simple scenario. In a boardroom, you install all the LED lamps. Most energy efficient boardroom. But just after a boardroom, who thinks to turn off the light? Just after a meeting, after a financial meeting, nobody cares. They all want to escape. I have gone through that life. You want to escape the boardroom. Nobody cares about how many lights are running or not. Now you have the most energy efficient light sources installed in the boardroom. But energy is wasted. Nobody is there. So it is always not only using the most energy efficient devices, most energy efficient sources. We have another dimension, how to use them in most efficient manner. That's the third point here. Second point, we have to optimize all the devices together in order to get the best. You have the efficient devices, you have a mechanism to use them most efficient manner, then the outcome will be more efficient than when the system runs on its own. Then when we are running the system, we must have a lot of data. Rather than earlier case, now the system, buildings generate a lot of data. What's the temperature has been for last couple of days. How the outdoor temperature changes, how the lighting condition changes. So based on this, all the historical data, what we can predict. It's data driven. System can record this data. Then they integrated with national infrastructure. Again, you would have, if you have listened to the very first presentation, earlier when we were putting up a building, we were simply confined to how we can get water, how we can get electricity into our building. But now we always talk additional topic, how we can get the data line to the building. It's there, always there. People call to the relevant utility supplier, relevant service supplier, how we can get internet service to my building. The situation has changed. Next thing is, when you are connecting your building with these national resources, you can't use everything from the system again, because that is for others as well. So you have to ensure that the usage within your building, within your infrastructure is minimum only for the productive outcome. So what are the tools available? Of course, again, these few topics highlighted. We have smart metering system, we have IoT sensors by which we can measure all the readings, and the building automation system or building management system. We will have controllers which will record each and every variation and makes the decision. And the cloud analysis. We don't want to have a lot of servers and high-tech devices installed in our premises. Instead, all the data could be transferred to relevant cloud and your programming will be there. So if I'm quickly highlighting these few lines here, we have to have sensors which will be monitoring this prevailing condition, and the controllers have to be there. If it is a building automation system, we will be using controllers like DDC controller or PLC controller or standalone edge controllers. Communication have to be there, because when you are harmonizing all the system, there must be a lot of communication in between these devices, for which we have to have protocol. Protocol means another language. So there are a number of languages we work with, such as BACnet, Modbus, IP network, and MBus. MBus stands for metering bus, where you get all the meters connected to one single network, and all the meter will be delivering their information. Then the intelligence component has again come into the picture, so that you can have AI component, and by which you can get some predictive analysis as well. Finally, visualization. You will have your mobile phone on palm top, or maybe on your laptop computer, or on your mobile phone, you will see the current status. This makes our day-to-day life very easier. So integration is more important than individual component. Now systems are not running in isolation. They will be communicating with each other. They will be harmonized, so that we will get the optimization far better than when they run individually. So this diagram which I have extracted here is from a running building right now in Colombo. So one of my colleagues gave me. So here biggest energy chunk is due to the air conditioning system. Biggest chunk is due to the air conditioning system. So being a tropical country, air conditioning plays a big role in our Sri Lankan context. So if you look at this particular diagram, you will see in order to bring the proper climate condition for you, there are a number of devices are working in harmony. Even it is happening right now. In order to keep me around 190 people in this particular boardroom, there are a number of devices are running in there. But the issue is, now you would see a lot of people are coming and going out. The load is always varying. If you run all the devices in a constant value always, there will be a wastage. So that's why we have to have another third component which are looking at each and every devices here and giving the command in order to adjust the output so that it will meet the load condition. So that's why we are installing building automation system. This is an actual picture from one of site that we are working with. So all the controllers in this photograph that you are seeing will be monitoring the prevailing condition, and it will be giving the outcome. It will be giving the command signal to all the hardware connected. So now we have a lot of concept like AI-based chiller sequencing, improved operational algorithm. And one of the important thing I want to highlight here is that when we are doing the initial financial, I have seen we go with limited budget. So that sometimes it's very difficult for us to understand what sort of operational algorithm that we have to define. So we have now a lot of AI-based tool. Based on the hardware availability, we can decide what sort of operational algorithm can be produced. Next thing is, if you want to improve something, if you want to optimize something, you must measure it. Without measurement, we don't know what is happening. Only when the light bill comes, we know something had happened, but it's too late now. But if you know where the consumption is happening individually, of course you can take the remedial action. Again, this photograph is from a site that we are working right now. You will see each and reading from each and every flow, and the device wise, flow wise, readings are available. So if you see some anomalies, if you see some strange operation, you can take the action based on the readings available here. These are not very expensive component right now. And then again, one important factor is we see a lot of renewable sources are also utilized in the building application. But the problem with renewable sources is they are not stable. They are always changing. So if you are using natural lighting for our office illumination, again, we have to ensure that required light level is prevailed in our office table. But the problem is outdoor lighting is not always same. So again, we have to have a mechanism where we measure the outdoor light condition, and it will work with artificial lighting in conjunction with, in order to ensure the required light level on our working table. So again here also you can see, as one of our previous presenter showed us, nowadays with this lot of renewable energy initiative, buildings are not simply energy consumer. They can also produce the energy and contribute to the national grid. So before getting into the last slide, I have to highlight, when you get this lot of digital component running together, it is mandatory that you have to have some security, and the cyber security comes into the picture as well. I'm not going to talk about each and every topic here, but I will highlight one more thing. One practical example that I went through when I was working with one factory. So when it comes to IT, people think it's always, IT department. So if you fix a CCTV camera with IP-based CCTV camera, I have seen even IT manager has to come from couple of kilometers away from the head office just to open the rack. He comes and put the key and open the rack, and the rest of the people fix it. So please remember, nowadays we have two things. One is called operational technology, other one is IT, which is called information technology. Operational technology is basically for engineering department, through which you can run your CCTV system, your building automation system, your access control system, your public addressing system, your television system, Wi-Fi system. Those all could be run your operational network, which is totally isolated from the IT department. IT network, where you get all the ERP and HR information and financial information would be running in the IT network. So as long as you maintain this particular demarcation, your security is also improved. But other than that, we have some other aspect like encryption data, because data security is a number one factor when you digitize everything. So smart building without cyber security is very vulnerable. Please remember that as well. So finally, energy efficient buildings are not just MEP systems. They are intelligent digital ecosystems. So these all work together. And please ensure if you are to get into this efficient system, if you are to get this in digital era, engineers have to do a major role there. So you have to do a major role in that. Thank you very much.
Thank you very much, Engineer Jagat, for that insightful and engaging presentation. With that, ladies and gentlemen, we are coming to the end of the first segment of the presentations, the first 4 presentations, but don't misunderstand me that you have to listen 3 more presentations after a while. So, until then, let's take small energy to ourselves. Engineering is not about precision and calculation, but it requires a little bit of artistic and innovative approach as well.
To add a touch of artistic brilliance and to energize this evening, we are having our talented members from Young Member Section of IESL. So let me invite Mr. Thisum Manmitha, Mr. Ranidu Karya Peruma, Ms. Duhari Dharmaratna, Mr. Janidu Atapattu to a live musical performance. Ladies and gentlemen, shall we give them a big round of applause?
Test on, test on.
Other Thank you.
සඳරෑට ඇවිදින් හේනේ කලෝව බිඳ රන් කෙඳිසේම රන්වන් ඉරිඟෝ ඉබිනවාද තුන්යම හීන දැක දැක මොටදැයි ගෙදර ඉඳ රන් කඳ තාම පැල් රකිනවදෝ නිදී නැතිව හිතයි මට මී අඹ කන්න කිරවුනි එන්න එපා හෙට මල් පිපුණාට ගෙඩින තාම අඹ ගහට පුන් සඳරෑට ඇවිදින් හේනේ කලුව බිඳ රන් කෙඳිසේම රන්වන් ඉරිඟෝ ඉබිනවාද තුන්යම හීන දැක දැක මොටදැයි ගෙදර ඉඳ රන් කඳ තාම පැල් රකිනවදෝ නිදී නැතිව
Thank you very much, our future leaders, for your wonderful performance. Ladies and gentlemen, shall we give them again a big round of applause for their wonderful performance? Hope you all have sufficiently energized for our next 3 presentations in line. Accordingly, now we are moving to the second set of presentations by our sectional committees. Now we have an online presentation presenting from the IT and Computer Engineering Sectional Committee by Engineer Dr. Samudaya Nanayakara. The title of his presentation is Data-Driven Environment Product Declarations for a Sustainable Future through Advanced Digital Technologies.
Good evening. Hope you can hear me properly. Can you hear me properly?
Check one.
Can you hear me?
Yeah, we can hear.
All good? Okay, good evening, everyone. Shall I start? I can't properly hear you, the controller.
You can share.
Yeah, I shared my screen, and can you hear me properly?
Yeah, we can hear you properly.
Okay, good. Okay, good evening, everyone. And I would like to acknowledge our ISL president, president-elect, and all council members, past presidents, CEO and staff members, and distinguished guests, and all the students and others gathering here today, and also Zoom participant as well. And today my presentation on data-driven environment product declaration for sustainable future through advanced digital technologies. I will go through my presentation outline a little bit about what is this scope and my research areas and today's discussion, and a little bit introduction about the EPDs and simple 2 examples and EPD related different levels and challenges, and couple of current research going on that space. And with the multidisciplinary or within the engineering discipline, but multiple different areas, I will try to minimally using a technical terms and try to present my presentation in a simple format. And if anybody would like to have a later discussion, I can have it later offline. And sustainability is a very big area. According to Brundtland Commission 1987, they proposed there are 3 pillars: social, environmental, and economical sustainability. I'm today only focused on the environment sustainability area, not the social and economical. And there are another different sustainability guideline from the UN 2015-17 goals. According to that, this is more toward like innovation and that type of area related sustainability. When I move into my research, especially I do most of my research on the advanced digital technology area plus sustainability. And thank you so much. And organizing committee, Engineer Mangal Silva and Dr. Madhav invited me this topic today. I work on many sustainability related research on the carbon estimating, different type of embodied carbon and operation carbon estimating, circular economy area, and data-driven EPDs are the some sustainability related research. Most of the time, this research is backed by advanced digital technology. Many digital technology related research are usually conduct, and like a very advanced robotic related, like a humanoid related research, something like a hazardous operations, similar type of things. If you see in very recent China New Year that showcase about Unity G1 robots, so similar robot we have with the very high advanced 40 degree of freedom level humanoid. So mainly this one we use for doing some kind of the hazardous operation, likewise things. And some augmented reality related research, some thermal image sensing and thermal comfort related research. Previously engineered, Jagat highlight about like energy efficient building. So those building mainly controlled by some kind of IoT and other advanced digital tool. Beyond that point, we conduct this research mainly on identify the participant or the people inside the thermal comfort and adjust temperature and things and optimum level by using thermal image and machine learning and deep learning related algorithms. And many drone related research and previous one other presenter also highlight about they are utilizing drone based tower observation and conditional things, similar type of things, and thermal enable, LiDAR enable, and very recently another PhD started in the air quality observation, dynamic air quality observation about PM 2.5 fine air particle related research through drones and identify the air quality to that one mainly based on deep learning and drone based data collecting. And a lot of deep learning research and large language model related research and virtual reality about like health and safety training and things that type of thing. LiDAR scanning, it's a more laser similar scanning about environment with the 3D point cloud, and a lot of IoT, especially low range like a Zigbee and Z-Wave related one to capture environment data like temperature, vibration and similar type of thing, as well as very long range LoRaWAN similar technology as well for the digital twin and other systems. And a lot of research on blockchain related area about data management, enabling trust and digital governing systems and machine learning related research. So these are the different research space of my research area with the sustainability. I'm not going to the every detail with the limited time. So before moving into, I would like to give you some small analogy. If you read the Alice Adventure in Wonderland or Alice in Wonderland book, after Alice went through the rabbit hole, she asked some question from that laughing cat about the different roads. So cat asked where you want to go. Then Alice responded as, I don't know much about that one. Then cat responded about, then either way it's not a problem. And I can remember Dr. Narendra highlight about the and values and things about the uncertainty, because it is really hard to calculate most of the time. And engineer Jagat highlight about necessary about measuring values and things. Similar way, when we talk about sustainability, most of the time we talk about sustainability, but we don't know extract carbon emission, energy utilization, or water consumption, or maybe different type of the waste generating or global warming potential. We don't know. Sometimes we know the numbers, but most of the research showcase that the numbers are totally different and the values are not correct. So my research and my area is today presentation is how we can calculate and make that numbers and measurement in correct way as a engineering decision making purpose. So I'm not focus everything as previously I mentioned, only going to the data-driven EPDs, mainly utilizing IoT, blockchain, and machine learning and large language models. And this is the overall today's scope. And when you talk about environment product declaration, it's maybe a little bit new terms for you because Sri Lanka, we don't have a environment product declaration related program center. And however, I'm not going to mention one of Sri Lankan cement manufacturer got one of their product about EPD or environment product declaration. It is about the describing environmental impact from the particular product overall life throughout its life cycle. It may be a cement, it may be a computer, it may be a food, it may be a cloth, whatever the products. So throughout the life cycle, what is the environmental impact from that product is calling to EPD. It is based on the life cycle assessment data, and it's verified by the third-party agency. And we have to follow the ISO 14025 guideline for that one. It's identify carbon footprint, energy usage, water waste, and almost every impact from this particular product to the environment. And when you talk about that one, it's promoting the transparent and support environmental responsibilities. If you know this value, as a simple example, if you are maybe a civil engineer, you want to pick some kind of the steel product for your next building. If you know these things, you can simply decide which one is the most environment friendly one. You may be a computer science engineer, you want to pick some kind of the equipment. So you can look at this environment product declaration, and you can say what is the least environment damaging product to your project. Similar type of things, we need these numbers and the extract value. So environment product declaration is that scientific document give us these values. And mainly many European countries use that one. Now USA, China and India, Australia, New Zealand and many countries use EPD. And unfortunately, still we do not have a national EPD program operator. So if you want to get the EPD, you have to communicate with the International Other Center. And it is common for any product. It can be a construction material, it may be industrial manufacturing or food and agriculture, apparel or anything else. So simply, I will give a simple example. As this is the carbon emission about the wine, 750 milliliter, like a similar bottle size wine bottle. So when you calculate that one, they can calculate about the different era, vineyard, winery, and the bottle and the storage, and even next level about transportation and things. And we can include this value. Simple example about this type of bottle, it's roughly around 1.5 kilogram carbon emission from that one. So if you know this value, you can make a proper decision based on that one. So this is a very simple one. But if you go into something like a built environment, I can't remember, engineer Jagat mentioned about like a 30-40% about energy consumption or something like that. That is happening in the built environment, especially building sector. Simple example about cement bag or something, around 50 kilogram cement bag, roughly 45 or more, we emit the carbon and global warming potential, and many factors are there. So if we know those things, we can select most suitable material for our next project. So that is our requirement. So if a simple example around cement manufacturing, there are around 20-30 these type of parameters like global warming factors and energy demand, water usage, similar type of thing. Or if you look at the simple aluminium window frame with the glass, there may be around 100 data points. So it is a very complex document, but if you can decode that value in the proper format, we can get the real impact and identify that one. And a little bit more into the EPD area, we can categorize EPD in the 4 levels. Very generic one is industry-wide EPD. It gives us some generic terms in the design level. Engineers can utilize that one for the initial estimation about the carbon emission or impact and those kind of things. Then the next level is a product-specific EPD, a little bit more fine-tuned version, but product-specific. And next level, most accurate one is the facility-specific. There can be multiple facilities like factories. So different factories consuming different type of the energy sources, different type of material, or same material with the different transportation. So it's about facility-specific one. Ultimate goal is we want to move into supply chain specific EPDs, because some products, it may be production happening, as example, simply your project is in Colombo, near the Colombo area, but the production happened in Anuradhapura. Its transportation give a lot of energy consuming about the diesel and the fuel, something like that. So we have to calculate those things. So when you talk about that one, you can understand how complex this process. So these are the key challenges. This environmental product declaration is a very useful document. However, it is very complex and time consuming and costly process. And there are some kind of scoping issue and various measurement parameters, different parameters. And it is really hard to utilize in the proper format, even that is a useful document. So this kind of challenges, 2 of my research mainly focus on how to, in that especially producing area, how to mitigate that complexity and the cost involvement and time consuming side. And also other side, when you are using it, how to utilize that one in a more easy manner. So first research I want to share with you about automatic EPD creation using machine learning. So this process, we utilize web crawling about the currently published EPD document in the PDF format to the web. and 2 levels semi-automated data processing happen, classification and things. Then we use training and testing to the machine learning model and develop EPDs. So this is not the highly accurate one compared like a supply chain, but it is beyond the generic category. It's nearly accuracy we can get into the facility specific EPDs. If you can find some data, and this is the initial level, but if you can feed some data about the location, energy source and other things, we can improve that one. So this process, we can cut down the lot of time consuming this process and the accuracy issues. And beyond this point, we can enable additional information capturing to the supply chain, energy and other things to the IoT devices and give more visibility to the blockchain. This process give more accurate EPD for next generation decision making through EPD related environment impact. That is the first research I want to share with you. And second one is called Simply EPD. This is very simplified version of EPD, because previously I mentioned about EPD document. There are around 40 to 50 or sometime around 100 parameters and different values. So it is really hard to make a decision just based on that document. So how we can simplify this document and make a simple decision based on that one? That is this research. So we utilize the current level data set and mainly use the large language model to train that chatbot similar help tool, and utilize currently available EPD data and clean, and we train that one. And simply then you can utilize that chatbot to communicate and ask. You can provide, as a simple example, 2 or multiple ready-mix concrete, and you can ask about what is the lowest embodied carbon impact from these 2 products or something. So it's not only consider the carbon emission, there may be other like greenhouse gas emissions are there. It will consider all those factors and give some kind of the fair answer to the decision maker about these things. So considering all the factors, combine everything and make a good outcome. Actually, this research, last year we won the CIB Keith Hampson Industry Award 2025, around 60 countries participant institute. So this is that one. These are the 2 different things I wanted to share with you today with a simple manner and a couple of references, but I want to give you 3 take-home messages to that one. So we have to consider what are the potential tools to solve today's environment challenges, not only the environment, it's maybe social and economical as well. Digitalization is one of the key things we can utilize today. As previous multiple presenters mentioned, that one we can simply use like a machine learning, large language model, IoT and edge computing like tools, and those are not much expensive. Or there are some expensive tools like a robotics, drone and other things as well. So based on our requirement, we can utilize those things. And especially if you are undergraduate or current student, think about how you can utilize these tools to solve tomorrow's problem. And second thing, so we have to think about what we are going to trade off with that one. There may be some expensive, there may be some massive energy utilization behind it, something like data centers and other things. So even if you try to mitigate this environmental impact to these tools, so what is the other side? We are compromising about data centers and energy utilization and things, or privacy issues or cost factors. So we have to consider these things as well. And third, my take-home message for you, there are many our very prominent engineers and some especially sustainability area and green area experts are there. Think about establishing Sri Lankan EPD program operator, and it will enable multiple industries. It may be apparel, it may be a manufacturing, it may be a construction, and almost everyone to join with that one and make a clear, transparent, visible environmental impact from their product. So those are the things I want to share with you today. And I want to thank the organizing committee and especially Engineer Mangal Silva and Dr. Madhav invited me that presentation today. And thank you so much. And hope you have another couple of presentation and enjoy the day. Go ahead with that. Thank you.
Thank you very much, Dr. Nanayakar, for that insightful and informative presentation, and highly appreciate for sharing your expertise knowledge with the audience today. Also, on behalf of ISL, thank you very much again for, even though being in a different time zone, your commitment and your dedication towards sharing your expertise with us. Before moving to the next presentation, ladies and gentlemen, there's a small announcement from our organizing committee. It's a delicious announcement, really. There's a delicious dinner fellowship arranged at the end of the events. Therefore, stay with us until the end of the events. Don't leave the audience halfway. So, by the end of the event, let's enjoy the whole day together. With that, ladies and gentlemen, let's move to the next presentation. On behalf of Chemical and Process Engineering Sectional Committee, I kindly invite Engineer Dr. Manjula Sirivardhana to deliver the presentation on greenhouse gas mitigation strategies and sustainable transition towards carbon net zero by 2050. Over to you, Doctor.
Good evening, everyone. I'm very proud to stand in front of you, such a distinguished gathering like you all, and also I'm very proud to stand here as the one and only women resource person in today's event. So I'll be talking on the greenhouse gas mitigation strategies and sustainable transition towards carbon net zero 2050. There I will go through the global net zero roadmap, which is developed by International Energy Agency, and the upcoming innovations in the net zero path. Then I will move into the Sri Lanka context and the suggestions for the net zero roadmap. So climate change is global. Some policies might be globally influenced, or like some decisions may be taken globally. So what if the fossil fuels are phased out in another 15 to 20 years? So we need to have an alternative source of fuel in the pipeline. Therefore, it is important to follow up with the global trends, policies and technologies. Need to adapt to the most appropriate country-specific net zero path. Here I have highlighted that though Sri Lanka is one of the least contributing countries to the climate change, we are a very vulnerable country to the climate impacts. Energy sector net zero roadmap 2050, the global roadmap I have seen here, as some of the previous presentations also highlighted. If you look at the first line here in the figure, the electricity generation, as you see in 2020, the fossil fuel consumption is 61% in electricity generation, and by 2050 it is almost disappeared. Like it is replaced with 88% renewable energy, and also the 12% yellow color part is the nuclear and like a small quantity of fossil fuel, which is facilitated with carbon capture and storage. So I will not much talk about the electricity generation because it's already covered by some other presentations. So in the industry, the heat generation is a significant component of the energy consumption in the industrial energy. So in the industrial energy part, you see here in 2020, 89% of industrial heat is generated through fossil fuel, which is going down to 10% by 2050. So this fossil fuel heat is replaced with renewable energy and also electricity from renewable energy, plus this 38% here, 38% like green hydrogen and other source of renewable fuel. Also in the transport sector, as you see in 2020, like 90% of the fuel is fossil fuel here, as you see here. Fossil fuel. Then by 2050 it comes to 10% fossil fuel. The 53% of indirect renewable means electricity generators from renewable and also 30% like hydrogen and other sources. This is the policies for the phasing out of fossil fuel by 2050. The electricity output from unabated fossil fuel is fall to 40% in 2030 and virtually disappears by 2040. So like plants run less or retired or retrofitted with carbon capture and storages. So fossil fuel GHG emission fall by 97% to in 2050. These like nuclear energy and renewable energy storage will take the place for base supply of electricity by 2050. These ones I will cover more later in the next presentations, next slides. This is industry sector emission, especially the heavy industrial parts like chemical industry, the steel, cement, and other heavy industries. As you see in the first figure down there, the heavy industrial emission is reducing rapidly by 2050. This is mainly due to the second figure. You see the main like mitigation components are like 50% are mitigated by the hydrogen and carbon capture and storage. There are other elements like energy efficiency, electrification, bioenergy, so on. So hydrogen and carbon capture and storage itself mitigate the 50% of heavy industrial emission by 2050. Here I have shown one example for cement industry, like in 2050, like 90% of mitigation is through carbon capture and storage, as you see in here. This is like net zero global net zero roadmap. I have given here the source of the figures. In Sri Lanka, we have heavy industries which require high temperature heating, like a ceramic and tile industry, porcelain, cement industry, glass, steel, tire and rubber industry, etc. So we need to think of these things going to green hydrogen or carbon capture and storage that I will be explaining further later. Also there's a huge leap in energy innovation towards 2050, as Dr. Narendra also mentioned. Sometimes some of the technologies we may not see in the market today. Like you see in the first figure here, like most of the mitigation components in 2030 comes from the technologies that are already available in the market. But by 2050, most of the mitigation options come from the new technologies that may be in the demonstration or like prototype phase at this time. But by that time, after 2040s, they are like competitive technologies. That's how it's predicted. Like in the next figure, you see by 2030, with the already available technologies, like there's a huge leap in renewable energy, and also electric car sales are booming, and also energy intensity of GDP is reducing. These are some of the examples of energy like innovations in the coming decade, next couple of decades. Like the biggest innovation opportunities concerned advanced batteries, like battery chemistry and so on, and hydrogen electrolyzers and carbon capture and storage. The battery demand grows rapidly, and also the battery energy density is increasing rapidly. You see here in the right, this figure. Also, I have given an example of already commercially deployed iron air battery in the US, deployed by Google. That means the battery chemistry is also developing very rapidly. The specialty of the iron air battery is that it can absorb like 3 to 4 days or up to 5 days of intermittency in the renewable energy in the grid. Like it is not just day and night intermittency, it is like up to 4 days intermittency. It is like charging, discharging, like that. The other one is hydrogen-based society. By 2050, vast majority of cars on the street will be running on electricity or fuel cells, and also hundreds of industrial plants will be using carbon capture and storage or hydrogen around the world. This is how the hydrogen is predicted to be developed in the figure. Also, though we have to follow up with the main global policies, each country should take into account their own like economic and economic considerations, social and environmental considerations, as also the country resources availability and so on. So each country should develop their own net zero path. This is, I have given the specific one in Japan. Unlike the renewable abundant countries, they are developing their net zero roadmap based on the hydrogen. So Japan is developing like exploring the opportunities for hydrogen production technologies, storage technologies, and fuel cell technologies, and so on. As you see in the figure, most of the hydrogen will go into the industrial sector in Japan. This is from their net zero roadmap. So we have to find which one is better for us, even though we follow the basic global policies. With that, I come into the suggestions, my suggestions for Sri Lanka net zero path, like nuclear energy to replace coal power, like by, as you all know, by 2044, the Norachole power plant will be retired. So by that time, even if we go for other fossil fuel, it should be fitted with carbon capture and storage, or it has to be alternative fuel like nuclear power. And also nuclear is one of the clean source of GHG in the energy sector, like it doesn't generate greenhouse gas. And also use of curtailed renewable energy for green hydrogen production. This figure I took from the long-term generation and expansion plan of the CEB. So here the red color parts are the surplus renewable energy generation that is to be curtailed during daytime. With that, we propose to use this daytime surplus renewable energy for green hydrogen generation and use them in the industrial applications where there is a high temperature thermal energy need, like industries like ceramic, tile, cement, glass, steel, etc. And this hydrogen can also be blended with LNG for power generation, like blended hydrogen mix with the natural gas. And also this curtailed renewable energy can be used in EV charging. We propose to transform, we propose the transition to electric vehicle as one of the major strategy in our roadmap of carbon net zero 2050. Lifetime GHG emission of the electric vehicle is much smaller than the conventional IC engine, like internal combustion engine, even in the dirtiest grid. As you see in the first figure, I think this is a general US grid. You see the first column is the IC engine emission. The electric vehicle in 2025 grid is less than 46% compared to the IC engine vehicle. And when the grid is getting greener, the difference is higher. The amount of lower in the greenhouse gas emission in the electric vehicle is 76% compared to IC engine in 2035 grid. Also in the second figure, here you see this is the emission for electric vehicle, this is plug-in hybrid, and this is hybrid, and this is gasoline petrol engine with the same distance and so on. So we think time of use price structure, like innovative price structure, will promote the use of daytime renewable energy for electric vehicle charging, and also the electric vehicle infrastructure is rapidly developing in the world. With that, I come into the conclusion, like climate change and greenhouse gas related policies should align with economic drive in the country, and also fossil fuel supply and prices, future potential global pledges, and also the geopolitical situation, also energy security and innovation in the future, and also the country-specific sustainable development goals. In the net zero path, there is a huge decline in the use of fossil fuel, boom in renewable, increase in nuclear energy, hydrogen as a fuel in the industry and power generation, energy storage, boom in electric vehicle, and also carbon capture and storage. The innovative technologies may lead the greenhouse gas reduction beyond 2030. Efficient hydrogen production, AI-induced reduction in energy intensity, advanced battery chemistry and technology, and carbon capture and storage are dominating. For Sri Lanka, in addition to renewable energy development, we propose the use of surplus daytime generation of renewable energy for hydrogen production and EV charging. The hydrogen is used for heavy industrial heat applications and as a blend in power generation. When fossil fuel, especially coal, are phased out, beyond 2044, nuclear energy is a worth consideration for the base load management. Thank you. These are some references. I also take this moment to thank the Chemical and Process Engineering Sectional Committee and the chair, especially the chair, Engineer This Lienage, for giving me this valuable opportunity. Thank you.
Thank you very much, Dr. Manjula Sirivardhana, for your inspiring presentation. Finally, we are reaching to the last presentation of the day. To conduct the presentation on behalf of the Agricultural and Plantation Engineering Sectional Committee, I would like to invite Engineer Mahesh Chaturanga to deliver his presentation on Precision Agriculture and Plantation Sector Decision Support Systems using IoT and RSGIS technologies.
Good evening, everyone. Actually, this is the last one, okay? Okay, I'm Mahesh from ACCIMT. Actually, it is a pleasure to hear with you today. It's an engineering day in here. Okay. Precision agriculture, very famous topics. We know in our traditional agriculture sector, we use fertilizer and it's spread by hand to the entire field. Okay. But nowadays, you know, we use drones to spray the fertilizers. Previously used hands. Now we use the spray drones for them. This is called precision agriculture or not. This is not the precision agriculture. Okay. This is called digitalization. We replace the previous technologies by using the modern advanced technologies. Digitalization. This is not the precision. What is precision means? Api ඕන තැන බලලා විතරක් පොහොර දානවා. We identify the required input, and the right time, and the right amount in the right place. Okay. This is precision agriculture. Okay. Why do we need precision agriculture is the next question. Because of that, the global population is getting growth. Okay, now it is more than 8 billion. Okay, we need to feed them. Okay, how do you feed them? Using finite resources of Earth. Okay, Earth resources are finite, but our requirements are infinite. That's the reason. Okay. You see this one? This is called Earth Overshoot Day. Overshoot Day means Earth has capability to do regenerate resources for a particular year. අපි ඒක ඉවර කරන දවස තමයි Earth Resource Overshoot Day means. Okay. If we live like resources generated by years finished in February. අපි කටාර වගේ හිටියොත් February වෙනකොට අපේ resources ටික ඉවරයි. But now you can see as a global average, our overshoot day is getting earlier. In 1970, here, now it is in July. Okay. Now it is in July. It means that we drink our future generations' milk. අපි අද කන්නේ අපේ අනාගතේ දරුවන්ගේ කෑම එක. That's the reason, okay? Okay. You can see, if some person lives like USA person, we need 5 Earths to feed 5 Earth resources need to feed our requirements. But if you like the Sri Lankan, we need 0.81, 80% of Earth to feed our nation. Okay. In Sri Lanka, we annually spend around 200 million US dollars for fertilizer importing. Okay. Also, the fertilizer subsidy we spend 19 billion rupees per annum. Okay. This much of amount we spend for the fertilizers. Okay. Also, in agriculture sector, we know to feed that amount of huge amount of populations, we need this much of productions. But agriculture is the 30% contributor of greenhouse gas emissions. Okay, it's because of the deforestations, it emits deforestation. We know the forest works as carbon sinks because it goes to the carbon dioxide concentration. Also because of the applying more fertilizers, it causes to nitrous oxide emissions. Also because of the rice cultivation kind of things, it is caused to the methane emissions. But it's contributed 30% of global greenhouse gas emissions. It's caused to the climate change. It's a circle. That's why we need precision agriculture. How do you achieve this? Now we know we are in agriculture 4.0 versions. Okay. It is in digital era and smart agriculture era. The precision agriculture is the subtopic of smart agriculture, digital agriculture. Okay. To get this precision agriculture technology, we need precise technologies. Okay. These are the most precise technology nowadays we have. Nowadays, the special thing is we have all the requirement of all the required technologies available. Precision agriculture කරන්න ඔක්කොම requirement technologies අද තියෙනවා. Especially IoTs, GPS, UAV or remote sensing technologies, AI and data-driven technologies, smart machineries, and cloud computing platforms. Okay. Technology is available. We need to use it. Okay. This kind of technology constellation we call telematics, telecommunication plus informatics. Nowadays, you know, engineering and informatics, they are combined working. Called telematics. You know how this telematics works. Actually, precision agriculture is some part of the telematics works. You know, in US kind countries, people use a large number of fleet of instruments for their agriculture fields. But with few persons, few human involvements. How do they handle this because of this use in technology? They use precise technologies from GNSS satellites. It might be GPS, GLONASS, any kind of Galileo or something. Also, they use some IoT sensors. Also, they have smart robotic equipments, machineries. Combinedly, they use these technologies for providing precision agriculture things. Also, the crop management kind of things, they use these technology approaches. Also, establishing by the automatic weather station kind of things, they can, by integrating those techniques using the satellite technology kind of things, they produce some drought prediction models, flood prediction models, frost prediction model kind of things. Okay. And also by using the data handling techniques, because we are working with big data, with agriculture fields, so we can predict the yield and control the other kind of things. Okay. Also, we know we have farm automation techniques nowadays, especially indoor vertical farming technologies. These are the precision technology applications for the precision agriculture. Especially in vertical farming, in urban area, we know we have limited spaces, but using this hydroponic, aquaponics, hydroponics, and aeroponics techniques, we can grow, do this kind of precision farming technologies. Also, the security and theft preventions. I'm not going to deep in this kind of things. Actually, I wanted to highlight what kind of things we are doing in Arthur C. Clarke Institute for Modern Technologies. Okay. We have number of IoT development, especially agromet weather stations. Okay. We have established more than 20 agromet weather station, automatic weather station in entire Sri Lanka, especially focusing on the tea sector. These data are publicly available for the researchers and everything. You can go to the aws.lk website and you can use this data freely for your research works and everything. So, we nearly real time, we collect the data within every 15 minutes. We got the data from these IoT sensors. Okay. Nowadays, we are working on this data by integrating this data together. We are trying to model the, in the tea sector, there is a big effect called, which Bangladesh is called blister blight, Bibiliangamare. It's reduced 40% of tea production. By modeling this data, and we can give predictions, good predictions before happening this fungal disease. Okay. Also, we have developing some soil probes for the IoT devices for measuring the soil qualities. Okay. These soil probes are portable. Nowadays, it's commercialized, and we handed over these things to plantation sectors. They are using these things. These days are also publicly available. These soil data probes are portable. You can fix on some place, you can get the data, and you can go to another place and take the data. Also, we have developed some selective tea harvesters. When tea is plucking, most of the time they pluck the unwanted leaves. Okay, it's very cost to production loss. But we developed some. Now it is in textile mode. Some tea harvester plucking automatic plucker machine. It's selective. It's select the suitable pluckers and for the data. Also, we are nowadays we are integrating our ground level AWS data with satellite data to provide the national level weather forecasting system. Okay, it's working. I think end of the 2-3 months we can publicly available data for you. Also, in the drone technology side, we are developing drones. SCCMT has capability for developing drones. These are one of the fixed wing drones we have developed. Nowadays, we are engaged with our Air Force and peoples, and we have collaboratively developed these things. These multi-rotor drones, and also these are tail-seater drones. We are also this one is developed for the Sri Lanka Air Force. This is a hybrid drones with fixed wing and rotors. Okay, this is a point I wanted to highlight in this. I told you that the spraying fertilizer through the drone is not the precision agriculture. That's why I said that. The way of working this is, the first thing is we need to observe the field. Okay, in drone technology, we use this kind of multispectral camera. It has this kind of multispectral sensors. By using these sensors, we can calculate and estimate. We are called indices, vegetation indices. These indices are related to the photosynthesis, sometimes for biomass estimation kind of things. We calculate the crop stress. By calculating this crop stress, with stress mass, we feed into the fertilizer spraying drone. This is not a separate thing. We go and measure and come. This is a synchronized, simultaneously real-time happening situation. Okay, drone එක observe කරනකොටම දෙකම එක fleet එකේ යන්නේ. Okay, but nowadays Sri Lanka, I think people are nobody use these things. They use separately those things, okay? Not as fleet. DJI එක develop කරලා තියෙන ඒ විදිහට නමුත් අපි පාවිච්චි කරන්නේ මේ විදිහට. Then this spray machine go to the stress crop field and spray and go and stop spray. ඒ කියන්නේ අවශ්‍යතාවන්ට විතරක් ගියා නැවතුණා spray කරා. Okay, also we know in most of the community, not in Sri Lanka, they use this kind of drone technology for cattle field handling, and they have some, by using multiple different sensors, they can identify their health condition and so many conditions, like things. Okay, this is a pilot project we done for the tea sector using our own developed UAVs. Okay, this is for in Talawakere area. You can see it is RGB mentioned. This is normalized difference vegetation index. It is an indicator of crop health. Okay, simply. Okay, this is a pilot project we collaborated with the artistic like done with plantation ministry, and we know in Sri Lanka we are the third or fourth largest tea exporter. But you see in Kenya and Sri Lanka we have same extent of tea, but Kenya production is double from side than to us. Kenya apitota production. Now they are the leading country of the tea exporting. But Sri Lanka is only 55%. They are fourth. What is the reason for that? Okay. Sri Lanka tea sector contribute 1% of GDP to Sri Lanka, but our production getting lost in nowadays. So we try to identify the reasons for these things. So they suggest to tea sector to use the smart agriculture, precision agriculture technologies. So we did some pilot in Kotagala plantations. We have done what we did is we first mapped the entire area precisely using high resolution satellite images. We use deep learning models for that. These models is publicly available. So using this deep model, we precisely identify the extents of the area. Then we suggest to what kind of area should be used for the tea, for the fuel woods, and for the buildings and other things. Okay. Also, we provide them to some elevation-related property data, especially in slopes, aspects, hill shades, solar radiation. These properties are individually not important, but when we are modeling the things, it is very important because these factors are very important for crop yield, especially in tea yield. Also, we provide some hydrological analysis, how water flows after the rainfall. It is very important for take the soil erosion mitigations, preventions techniques. Water erosion එක නවත්තන්න අපි දැනන් ඉන්න වතුර වැටෙනවා කොහෙන්ද යන්නේ කියලා. But we can digitally map those things. So. Okay. Also, we continuously monitoring the field health, but you might not be clear in here, but it is very clearly indicate some factors. Stress crops. Crop stress වුණාම we can ඒක visualize වෙන මේක පෙන්න අපි continuously ඒක monitor කරනවා. Also, we did some yield forecasting and data point using satellite data. We know in Sri Lanka we use crop cutting survey for the yield forecasting. It is not a forecasting actually, crop cutting survey. But after harvesting, it gets more than 1 year to get the value results. Okay, make results again. It's not useful. We can do the decision making from that. But we develop some model. It can predict yield before one prior to the harvesting. Okay. How it works is in satellite we continuously monitor within every 8 days we monitor the crop field, and by using this satellite data, we can calculate the crop phenology. By using this phenology, it's very indicative of the biomass. We can estimate the crop yield by using the machine learning model. Okay, Also, you can use this kind of models to identify the start of the season, end of the season. Okay, this is the start of season. You get this Ampara district. It's in this Maha season. This normally. This is the end of the season. Maha season එක සම්මානයෙන් ලංකාවේ පටන් ගත්තේ නොවැම්බර් ඔක්තෝබර් වගේ ඒක ඉවර වෙන අප්‍රේල් වල මේ සැටලයිට් මොඩල් වල එක පැහැදිලිව පේන්න තියෙනවා. Okay. This is our model results for this compared with census data and our model data. This is a cultivated paddy area. This is a cultivated rice yield. Also, this is a paddy extent how varied from 2013 to 2019. Okay. අපිට 2000 කොහොමද අම්පාරේ වවලා තිබ්බ ඒරියා එක especially ගන්න ඕනේ. If you want to get the area of the Ampara district in 2000, we can get from the satellite data this model. Okay. It's my final one is how do we overcome the challenges? People are talking about so many research and everything. We can do this way, we can do this way, but in real ground we are not implemented those things actually. What's the reason? අපි research එකෙන් කොට අජාද කිව්වට එච්චර ground එකට ගත්තාම ground එකේ මොකවත් නැහැ. Because we have so many challenges. That's the reason. Okay. That's the reason why university researchers are not working in the ground. They have huge gap. We need to minimize these gaps. That's the reason. Can campus වල ඉන්න කාලේ අපිට වැඩ එළිය ගිහලා කරන්න බැරි ඒකයි. Okay. I want to you know these three words: digitalization, and digital transformation. We know digitization, we convert the data into the computer format, 1-0 binary format. Digitalization is we need to replace the existing technologies with this modern technology, but we need digital transformation. We need to convert entire system enterprisely to the new system. Okay? That's the way of working these things. අපි එකක් තනින් තන පොඩ කරාට ඔක හරියන්නේ නැහැ. System එකම convert කරන්න ඕන. But it has so many challenges. Because we are not ready to change. Because they are fear about job displacement. Technology is job replacement. That's one reason. And financial barriers, because we can easily talk with, we can use precision agriculture, but the technology is very expensive. So we have financial barriers. I put the solutions below. And poor internet connectivity. You know, we are talking about 5G, but in Colombo, but not in rural area. This is the case. Okay, you know that you are engineers. You are something you know more than me. In the Ditwa disaster in Sri Lanka, I think more than 12,000 mobile towers. More than 4,000 are failed because all the IoT systems and mobile apps and everything are going to sleep. එකක්වත් වැඩ කරේ නැහැ. يعني අපි ටෙක්නොලොජි කොච්චර හැදුවත් අර සිස්ටම් එක ෆේල් වුණා. කිසිම IoT එකක් කරන්න. We have also established IoT in Kotmale. It collect data, but we couldn't get because GSM doesn't work. That's the reason. Okay, these are the barriers. So we need to address them. Okay, data privacy and security issues are there because these are multidisciplinary data-driven systems. The privacy, we need some proper protocols. Okay. අපිට වකු ගඩුවක් ආය දෙනකින් ඉල්ල ගන්න පුළුවන් ඒ ඩේටා ගන්න බෑනේ ලංකාවේ. Okay, අපි ඩේටා දෙන්නේ නැහැ. මොනවද දුන්නත් අපි ඩේටා දෙන්නේ නැහැ. Okay, so we do not ready to release the data. So it's one of big barrier. Data integration and management. People are doing data with multiple sensors. Okay, people can say, okay, you can put the data into AI and you can get a model. But කරන අය තමයි දන්නේ කොච්චර ඒක difficult AI වලට integrate කරන්න කියලා data. So, also big data complexity of scaling technologies. Okay, we can't apply the technology in tea sector technology to the rubber sector. Also, we Sri Lanka have small plots, but you can use a fleet of machinery to this plot like as a USA. We need to customize the scale the things. Also, sustainability, environmental factors, increase energy use. Okay, increase carbon. We are planning to use some precision technologies, but precision technologies also consume the energy. we are not talking about that, but in previous nice presentations, people are addressing this component. Okay, thank you for them. Regulations and laws, you know the situations in the regulations laws in Sri Lanka, we are very difficult to place. Okay, our recommendation is we need to start those things anyway. Okay, otherwise we can't face this situation in the future. Okay, thank you very much. Sorry for my rapid fast movement because I have more than 80% slide, 80 number of slides. Okay, thank you so much.
Thank you very much, Engineer Mahesh, for that insightful and eye-opening presentation. A special area that we need to focus if we want to have a sustainable development as a country and as a nation. And with that, ladies and gentlemen, we are moving to the end of our technical presentations. And thank you very much, all the presenters. And ladies and gentlemen, shall we give a good round of applause for all our presenters here with us today. With that, we are moving to our next important item in the agenda, the panel discussion. It is not going to be just a panel discussion, it's going to be a collaboration with generations. To lead our panel discussion today, we have a very distinct academic and pillar of engineering education in Sri Lanka today. As the Dean of Faculty of Engineering at University of Moratuwa, his leadership continues to shape the technical excellence of our nation. To lead our panel discussion, it's my privilege to invite our moderator, Engineer Professor Jagath Manatunga, the Dean of Faculty of Engineering at University of Moratuwa, on stage.
Joining him on stage, I may now invite our student representatives from leading engineering faculties. Mr. Akila Prasad from University of Moratuwa, Mr. Tisen Laknidu from University of Peradeniya, Mr. Kaveen Nevmal from the Open University of Sri Lanka, Mr. Himaya Samarakkodi from Sir John Kotalawala Defence University, Ms. Pavarsin Sayalali Bhavan from University of Jaffna, Mr. Anjana Veerasinghe, SLEET. In addition to that, Mr. Lakshmikant Rajendran from Southern University of Sri Lanka, Mr. Dinit Lakshan from University of Ruhuna, and Mr. Mohammad Safi from University of Sri Jayawardhanapura will be joining online.
Good evening. President ISL, Engineer Kosala Kamaradeniya, President-elect, past presidents, council members, present and past, my dear fellow engineers, and there are lots of students. We are about more than 1 hour behind the schedule. Before discussing about innovations, let us be mindful of the time. We might have to have a digital clock somewhere here, not an analog clock on the back. Welcome to this panel discussion. So for the next 90 minutes, you will be listening to us. I'm sorry, 30 minutes. Yeah, today's theme, Smart Engineering for a Sustainable Future through Innovation and Digitalization. Now, when we say smart engineering, we don't always refer to technology per se on its own sake. We mean engineering that is data informed. That's what we were listening to during all the previous presentations, and also innovation led, and most importantly, sustainability focused, sustainability centered, and most importantly, engineering that improves lives of people across the country, across the globe. Engineering is a people serving profession. My dear students over there, can you please listen to me? I'm shouting here. Now, this is what we need to understand when we refer to engineering as smart engineering. Innovations are not always about gadgets. Innovative ideas, innovative policies, they are also innovations. So innovative ideas sometimes are much, much better than inventing a gadget. Now, without going into details, because we have only very limited time, a special feature of today's panel is to highlight who are here with me on stage, who are speaking here, who I'll be connecting in the discussion. We have invited panelists, not me, the YMS and Engineer Mangala, to be exact. So we have panelists from 9 engineering faculties across the country. I think 3 will be 1, 2, 3, 4, 5, 6. Yeah, 3 will be connecting online. I can see just one place here. Okay, let's see whether they are all here. Because these young engineers will soon be designing our infrastructure. They'll be shaping our industries. They'll be modernizing our services, and they'll be solving complex engineering problems that our small country will face in the coming decades. And that's why their views matter. Sustainability, innovation, digitalization, they are not abstract ideas. They will definitely influence the real decision making, how we manage water, energy, how we build resilient cities. Our infrastructure is not very resilient, that we witnessed a couple of months back, and how we improve our transport systems, healthcare, and how we protect our communities, and most importantly, our fragile ecosystems from climate risks and resource extractions, and how we ensure that everything that we do as engineers would serve the humanity, serve the society. These are just only a few that these youngsters can do tomorrow. The people who carry these decisions forward are the future engineers that I have with me today, but they will serve the country's society from tomorrow. So this discussion is very important, and listening to them early is important. Listening to their priorities is also important, their values and practical thinking of those who will lead the engineering in the future. We have just 30 minutes from now. The clock is ticking. I have 9 panelists, a big panel, the biggest panel that I have ever chaired. So I will limit my questions to 2, right? So if you divide two questions, 6, 8, 9 panelists, 8 questions, so you don't have more than 45 seconds for each question. So I have consumed 5 minutes already, right? Now, so that is the time rule that we have, and we will proceed in a preset order. I have informed you of the order, so we might not be able to take questions in between from the audience, which will take us to a cup of tea during the midnight. So we have Kaveen Newmal from the Open University of Sri Lanka here, right? And Mohammed Safi from University of Sri Jawadarnapura.
Yeah, so I joined virtually.
Okay, okay. So, yeah, Sri Javadhanpur is very far from here. And Akila Prasad from University of Moratuwa. All right, very close to me. Miss Avasin Cielo Libaban. How to? Yeah.
Pravarshini Sayalolibo.
Pravarshini, okay. She's from Jaffna. Oh, you came all the way from Jaffna. Thanks for that. And we have Lakshmikant Rajendran, Southeastern University of Sri Lanka.
Yes,
online.
Yes, online.
All right, okay. And then Miss Himaya Samarakkudi from KDU. Right, you're here. Danitha Lakshan from Ruhuna.
Yes, sir, I'm joining online.
Online, okay. We have all the three online, okay. And Miss Anjana Veerasinghe from SLIT. And Tisen Lakdinu from Peradeniya. Okay, all the 9 are here. So I will ask you two prompts very quickly, one after the other. Please answer the questions within the allocated time. If not, I will go on to the next question before you finish answering. Right, round one. Now let us start with Kavin Newmal from the Open University. So when we talk about 2040, 14 years from today, technology will be not the same as that we have today. It will keep on changing. But the core skills as an engineer and the ability to apply them to solve problems, local problems as well as not very local problems. Those who can adjust to this changing technology will thrive, survive, and will do better. And my question to you, Kavin, what skills should an undergraduate develop today to remain relevant in 2040? You will graduate in, say, probably this year or the next year, but in 15 years' time, you will be at the apex of your career. So how would you equip yourself to face the challenges that you will face in 2040?
Good evening, everyone. I'm Kavin Newmal, undergraduate at the Open University of Sri Lanka. I believe undergraduate student must be develop more than technology knowledge to stay too relevant in 2040. Firstly, I believe AI literacy and strong digital skills importance because future is technology driven. Secondly, I believe we need systems thinking and sustainability knowledge to design responsibility design or responsible solutions. So then also an interpretation mindset is important to create new opportunities. Finally, I believe communication skills and adaptability are key because future is change very fast. So thank you for giving chance.
Kavin, you touched upon AI and data systems, and also you said systems thinking and sustainability, and also you touched upon communication skills, adaptability. I think they are all important to be competent in a changing world. So my next question connected with smart technologies, the key word in the theme for today's event. So with the skills that you mentioned in the first question, the second question would be, what engineering problems in Sri Lanka would you most like to solve using smart technology? Just give an example, just highlight one example and say why it matters and why you chose that. One just a simple example from Sri Lanka that you can apply smart technology.
I think one major problem I would like to solve in Sri Lanka in traffic because traffic waste fuel, time, and increase pollution. So I believe we can use AI-based traffic monitoring system, smart signals, and data-driven route optimization to reduce congestion with sensors and real-time data traffic. Flow can be automatically controlled instead of fixed-time signal systems. This will save energy, reduce stress for people, and improve productivity of Sri Lanka, of the country.
Right. I think he mentioned a couple of things, future-ready skills to tackle real Sri Lankan problems, which is exactly what smart engineering should be. Capability with a purpose to solve pressing problems of the society. And without wasting any further time, let's move on to Muhammad Safi from University of Sri Jawadanapura. Can you hear us?
Yeah, sir.
Yeah, sustainability. There was a couple of speakers before this session. They spoke about they mentioned about sustainability. It's not only technical; it relates to social as well as environmental. And modern engineering is rarely done alone. It is a combination of all the three pillars, as Dr. Samudaya mentioned. So it has to be done in teams across disciplines. So my question to you is, now we always speak about engineer in society, engineering for society. So my question is, what does engineering for society mean to you as a future Sri Lankan engineer? Either you can focus on engineer in society or engineering for society. Human-centered outcomes, safety, affordability, blah, blah. There are lots of things. Can you respond to that question, please?
Yeah, first of all, good evening, everyone. I am Safi from University of Sri Jawadanapura. So the questions what Sir asked is made kind of the engineering society in the future, right? So my answer is, first of all, this is it's a practical question. It's suitable for the Sri Lankan environment for resources. So, and what I need to say is, we have the limited resources for the Sri Lanka. So we have to sustainable and suitable for the Sri Lankan environmental resources. Moreover, my answer is life improvement. That's mean enhancing the safety, health, and infrastructure and overall quality of life. Then, moreover, the cost of effective for the local economic considerations and concerns. So, and the thing is human-centered solution. So, as for the engineers, we have to find out the solution for the problems what we faced in every sector, in the environmental and the electronics in every area. So, my answer is that.
Right. Okay. I agree with what you said, and I think two pillars that we want to introduce: society focus and collaboration. So, if engineers can work with society in focus and collaborating multidisciplinarity, I think would serve the society. So, just skipping the second question, we will come back if the audience allows us to go ahead. So we will move on to the third panelist. I'm sorry, I'll keep you engaged, Safi. I'll come back to you if time permits. Akila from Moratua. Now, we are living in a global uncertainty. We have economic shocks, climate risks, and disagreements between countries, fast-changing technology, and these disagreements will also give opportunities for further innovations. So engineering needs purpose and direction, right? But directions should be to serve the humanity, not to destroy civilizations. Now, my question for you, Akila, what motivates you to become an engineer in a time of global uncertainty, economic uncertainty, political uncertainty, and also the environmental and climate uncertainties? Can you please share your views of why behind your choice and your answer?
Yes. I believe that question is more relevant in today's context and I am from University of Moratuwa. I am Akhil Prasad. Today's world are facing many uncertainties, and we can see global conflicts and economic instabilities and rapid technological changes. Not only that, climatic changes also there. And recently example, previous week we visited to Lunugamhera Reservoir, and the engineers told us they have sufficient water than before because this climatic changes. And they told us they can make hydropower also. At the same time, Sri Lanka has faced many natural disasters like Ditwa, which damaged many infrastructure and affected many people. And those all situations shows that our global and our world is not stable. But for me, that is not a reason to step back. It is reason to step forward. And I am motivated to become an engineer because engineers are the one who problem solvers. And engineering is not only technology, not only theory. It is always try to give practical solutions for the many problems and the all problems in the world. And as an undergraduate, we have to use our knowledge to do our best to national development. That's what motivates me to become an engineer.
Okay, thank you, Akhil. Yeah, I think, as I mentioned, engineering needs a purpose and direction. And also, what comes clearly from your answer is that even in the face of uncertainty, engineers, we have to stay grounded in motivation and we have to grounded in mission. Motivation to accomplish the mission. That is how engineers should think about in terms of in times of uncertainty. So thank you, Akhila. I gave you a little more time because you are from Moratuwa. Miss Pravashini from Jaffna, your turn now. Now again, going forward, 2040. I don't know why 2040 comes to my mind all the time. Sri Lanka needs, our country's needs will be shaped by, most probably by climate, food scarcity. I don't know whether we will face food scarcity as well, together with water shortages, energy, mobility, health. We have too many problems to think about. But the bigger question is, will engineers be able to build their solutions? Not only importing all our needs to make our small country self-sufficient in everything that we are capable of. And my simple question with that in focus, what kind of engineering solutions will Sri Lanka need most as engineers, what engineers can solve to serve the society in maybe 15 years time, 20 years time to come?
Good evening, all of you. I'm Pravashini from University of Jaffna. I think by 2040, Sri Lanka must need the climate resilient infrastructure to withstand flood and severe extreme weathers, and intelligent transport system which reduces the usage of fuel, and also the digital healthcare systems likewise, which we can easily diagnose the health issues, and the usage of solar power and the smart way of using energies, and the water management must be there. Thank you.
Yeah, thank you. I think you identified something very important. What we need as a nation by 2040. We should become technology creators, not just technology users. We rely on everything that we bring from other countries. So we have to be technology creators, my dear engineers, not just users. That shift is essential if you are very serious about a sustainable future. Sustainability is not just making all the resources available for the next generation, right? So that is the general understanding that we have. It's not, right? Becoming a resilient nation. Becoming a resilient nation. So engineers can put ideas together to make our nation, our country, resilient. Resilient in terms of all the problems that we discussed before. So let's become technology creators, not just technology users. Lakshmikant, now it's coming to you. Can you hear Lakshmikant from Southeastern University?
Yes, sir. We can hear you, sir.
Yes, yes. Now, moving on to digital transformation. Now, it is not, digital transformation is not automatically fair. If we are not careful, it can widen gaps. Equity that we are talking of, inclusivity, right? At the same time, development pressures are real, and we must balance the economic development and keeping all the societal elements together that will make the development sustainable. We can't leave anyone out. Now, coming back to digital transformation, Lakshmikant, my question to you related to digital transformation. How can young engineers ensure that digital transformation benefits all communities, not only urban communities and who can buy education and training? How can you ensure that inclusivity, equity is ensured in the digital transformation and the development process that is embedded together with that?
Yes, I'm Lakshmikant from Southeastern University of Sri Lanka. So for this question, I can say that as the young engineers, we have the big responsibility to make sure that digital transformation for benefit to every people. Because for that, we should encourage the rural innovation nowadays. So for that, we can say that many rural communities still facing the challenges to lack of the digital resources. So engineers should have to pay equal attention to the rural problems as much as possible. And technology-wise, we can say that all the types of the people, including who are the people living in the rural areas, they have few resources. So the digital solution must be cost-effective and easy to use for them. For all those things, the perfect example that we can say, the app called WhatsApp. Because in ancient time, in few years ago, we have used the SMS to communicate with other people. But in nowadays, even the ordinary people can use that WhatsApp very easily, because the unique is the easy access and in low cost. So by focusing these kind of things, I can say that digital progress can be reaches every community. Yes.
Okay.
Thank you.
Yeah, thank you, Lakshmikant. Yes, cost effectiveness, easy to use, and having access to technology. Those are the three things that you mentioned. So so inclusivity, reaching every community, and I strongly believe that development has to be fast, but it should not be careless. We have to be careful that all the sectors of the communities are included in the development process. So development has to be fast. It has to take place fast. It has to be carefully devised and planned. I think engineers need to take the lead in the development of the country to ensure sustainability. Himaya from the KDU. Himaya Samarakkudi. So before we design the future, we should define the person who will build it, right? Should be an engineer, definitely. Then once we identify the person, we should ask what personal contribution will each of these identified persons should contribute to making the country, to align the country towards sustainability. So this small concept that came to my mind brings us to identify someone as a smart engineer, right? How do you now, smart engineering was the key phrase in today's theme. How do you define a smart engineer in the context of our country's future, smart engineer?
Thank you very much for the question, sir. Good evening, everyone. I am Himaya Samarakodi from General Sir John Kothalawa Defence University. And a smart engineer, what that means for me is a smart engineer should be globally competent with the latest trends and everything that's happening, but also they should be locally relevant, because if you're globally competent in something that's not locally relevant, that is actually not of much use as an engineer, because as an engineer we should contribute to the society and everyone that's to the environment that's there around us. Also, an engineer should be like multidisciplinary, because suppose you're a civil engineer, just the fact that you know how to build infrastructure and everything would not be of use if you do not know how to handle computers and softwares and all of that, because as a civil engineer you need those knowledge in the industry. So you should be multidisciplinary. For example, I'm an electronic and telecommunication engineering student, so I need to know mechatronics as well when I go into the industry, bits and pieces of mechanical engineering as well. So we should be multidisciplinary. Like that, we can be a smart engineer in the current society. Thank you.
Thank you, Himaya. Now, to add on to that, I agree with your definition, your explanation, your elaboration. But on top of that, I think a smart engineer should have a commitment to turn a theme into action, right? The commitment will make the engineer smart. So without that commitment, I think the engineer might not be a smart engineer. But yeah, I agree with all the things that you said. But a person who is committed to make a theme into action, and I wish to see you also, and all of you, and all the students who are seated here as smart engineers in the near future. And moving on to the next round, Dinitha Lakshan from University of Ruhuna. Dinitha? Hello?
Yes, sir. Yes.
Okay, you are there. So your question, very short one, for focus and action and impact. Innovations reaches society faster when ideas become real solutions. Sometimes that needs entrepreneurship. And one of the biggest arenas for impact is climate resilience. We will focus first, I think we will focus on entrepreneurship and then climate resilience. Now, I have two questions for you, very short ones. Please give us very brief answers. Do you believe future engineers should also be entrepreneurs? If yes, why? If no, again, tell us why.
Yes, sir. Hope you all audible me. I am Dinitha Lakshan from University of Pune. My answer is yes. I strongly believe future engineers should also think like entrepreneurs. So they do not necessarily need to start company immediately, but they should develop an entrepreneurial mindset. When engineers develop an entrepreneurial mindset, they become job creators rather than job seekers. This is very important for developing country like Sri Lanka. Although entrepreneurship, the researchers and final year projects can be commercialized and transformed to the practical product or services. That's mean innovation does not stay inside the laboratory. It reaches to the society. And also, engineering-driven startups can create employment, support economical growth, and also reduce imports through the local solutions and even compete in global markets. So, in my point of view, the future engineers should combine their technical knowledge with business awareness and leadership skills. Then, finally, when engineers meet entrepreneurship, that is when sustainable nation develop truly happen.
Yeah, thank you, Dinitha. Innovation moves from ideas to impact, and you were referring to engineers as creators. Now, these engineers, when you look at engineers as entrepreneurs, creators, or innovators, how will that help Sri Lanka combat future challenges? I think one of the most pressing challenges would be climate change. How can engineers contribute to overcome or provide sustainable solutions to face climate change?
Yeah, it's Sri Lanka currently facing a climate change problem. But so engineering innovation is extremely important for Sri Lanka, not only fight climate change, but also to adapt its impact. First, we can use technologies like sensors and machine learning, and also modern communication system to build reliable early warning systems for floods and also landslides, which directly help to save lives and minimize economical damage. And second one, engineers should have major role in developing resilient infrastructure, such as improved drainage system, flood resistant road designs, and buildings that can withstand extreme weather conditions. At the same time, expanding renewable energies such as solar, wind is essential to reduce carbon emission and reduce our dependence on the fossil. So we also need effective coastal protection solutions to manage sea level rise and erosion, especially in vulnerable coastal regions. Finally, as I mentioned in previous presentation, the smart agriculture technologies like automated irrigation and climate-based crop planning can help farmers adjust to unpredictable weather patterns. So overall, engineering innovations gives us practical and scalable solutions to protect our environment and also strengthen the economy and ensure the more sustainable future for Sri Lanka with climate change.
Yes, yeah. Okay, yeah, thank you, Dinitha. Now sustainability, the path to sustainability, the way that I define it, you need to be innovations. I'm not talking of inventions. Innovations will lead to building resilient infrastructure, resilient systems, not only infrastructure, right? So innovative policies will build resilient institutional systems, for example. Innovative engineering solutions will produce resilient infrastructure buildings, for example, road networks, without which we can't achieve sustainability. So innovation, resilient systems, sustainability. That is the path, the way that I define. You might agree or you might not agree, but I am very convinced. Then coming on to Anjana Veerasinghe on my left from SLIT. Now Sri Lankan engineers now work in a global ecosystem, physically or digitally, online or physically. To thrive in this diverse global ecosystem, we need a mindset shift, degree first to problem first. Now let's look at the global engineering ecosystem. My question to you is very simple, but which needs a little thinking. How do you see the role of Sri Lankan engineers who are trained here in the global engineering landscape? Or you might term it as the global ecosystem.
Good evening, everyone. I am Anjana Veerasinghe from SLIT. So I see Sri Lankan engineers playing a strong role in global engineering field. So because of that, they can share their knowledge with other countries, and also they can work as innovation partners, and also they provide remote digital engineering services and becoming leaders in specialized technology areas.
Yeah, leaders in the specialized areas. I think that is something very important. I think the Sri Lankan engineers, they can be globally relevant, but sometimes they might need a mind shift to become leaders in specialized areas. This specialization needs to be identified and be selected very thoughtfully because certain digital tools might become obsolete by the time you study and by the time that you want to apply them in the field. And the last panelist, Tisen Lakdino, right. We'll close the main round with you. A sustainable future must reach the society at every level, from urban to the village. It's not a slogan. It should be a real, practical policy implementation. And as a powerful tool like AI or any other digital tools that we have, our values must guide our decisions that we take, right? Now, inclusivity is one thing, including every part of the society in the development activities that we propose. And my question to you, what is your vision for a digitally connected and sustainable Sri Lanka? Especially, how can you connect the urban with the rural? What I refer to as the urban sector of the society is resource rich, and the rural community not so rich in the accessibility to resources. How do you propose to connect them to make them involved in the development process? Because engineers have to take the lead, energy. Even we were listening to smart agricultural systems, even health systems. So you name in any sector, engineers lead the modern digitalization and modern technology innovations. So can you please answer my question? What is your vision for a digitally connected Sri Lanka, the future of Sri Lanka?
Thank you. I am Tisen Lakdino from University of Peradeniya. So my vision for a sustainable Sri Lanka is a self-sufficient ecosystem-based architecture. So we can achieve that by using IoT devices and IoT sensors that most of our engineers has tell again and again. We can use them in our farming, so we can get more crops and more value to our products. Also, we can improve the life of farmers by using these sensors and other IoT devices. Also, for the we can use e-learning systems and e-channeling systems. So the rural areas, person in rural area can get same benefits for the education and for the health sector using these e-channeling and e-education services. So by that we can make some kind of bridge to achieve bridge rural and urban areas. Also we can place micro grids in the villages, so they can get the electrical supply on their own. So the cost to give a direct electricity to those areas will be reduced, and also they can get their own kind of infrastructure for their daily expenses. By these things we can we can survive in the future, and also we can thrive in the future also. Thank you.
Yeah, thank you, Tisen. I think, yes, every engineer should have a vision, big or small, groups of engineers, engineering institutions, and the vision to serve the society. The vision to serve the society should be backed by values. Core values like ethics, we always learn engineering ethics, protecting privacy or respecting privacy of communities, fairness, transparency, So we have lots of values that we have to follow, promote within our professions to make our visions to serve the society better with a set of values embedded into it. I think we have taken more time than what is allocated. Mangal is frowning at me, and I don't know what he's. I am not looking at him. So I think we have no time for a second round of questions, my dear small ladies and small gentlemen. So we have had the opportunity to listen to 9 perspectives. So the whole day today we were talking of digitalization, digital competence with systems thinking and sustainability, and engineering and engineers should stay human-centered, serving all the communities. That is the strongest pillar in sustainability. And the future has to be multidisciplinary. And Sri Lanka must shift from users to creators, not only technology users. We have to be technology creators. And sustainability requires both innovations and ethically grounded in our own values and whatever that we believe as good things. And importantly, the young engineers, you have to be driven by a purpose to serve the society, to serve the country. And I might open the floor for any comments. No need. Okay, good. So as a last comment, I think we need to get back home before midnight, I suppose. So on behalf of the IESL, the organizing committee, the council, I should thank all the panelists for your crisp insights and being here with us. And I thank the audience for your attention and listening to us. And let us treat smart engineering not as a buzzword, but as a commitment to innovate responsibly, to digitize inclusively, and then to build a truly sustainable Sri Lanka. Thank you very much, ladies and gentlemen. So we will wind up with that small note. Thank you so much.
I want to make a special thank to our YMS chairman, Engineer Lasit Balasurya, for arranging this students panel discussion. Thank you very much, Lasit, for your very hard work. I think this is the first time in the history that we are organizing for this type of event on this World's Engineering Day. Thank you. Then I want, although he is not here, very big thank to Engineer M.I. Dean for accepting our invitation and having a wonderful keynote speech. Thank you. Then none other than Engineer Professor Jagat Manatunga, Dean Faculty of Engineering, University of Moratuwa. Thank you very much, sir, for your wonderful, I would say, wonderful moderation. At the last end, you gave some, how can I say? It's a wonderful event. Thank you very much, sir. I know you are really tired after council meeting today. It's a very busy day for you from Moratuwa. Thank you very much. And all the presenters. There were 7 presenters here, 1 from online. Thank you very much for your nice presentations. And all the student members who participated to the panel discussion. Thank you very much. Those who came all the way from all over the country. Thank you very much. And next, my thanks goes to our nice compeers, Harsha and Sudeepa. Thank you very much. And a special thanks to SLIIT campus students for arranging us an entertainment event. Thank you. Thank you. I saw Dean also. Thank you very much. And I want to make a special thanks to 2 organizations. One is actually 3 organizations. One is Arthur C. Clarke Institute for allowing us to present certain things. Then there's another special project. This is digitalization of terrestrial TV broadcasting project. Of course, ISO project director is there at the beginning. Thank you very much for allowing us to present, some of your information. Then we know today, actually, you all know in this particular place, we can accommodate only 140 people. Today, our number of participation has goes to 200. So we accommodated another set of members in our Mavisuru. And there are so many vehicles there. I want to specially thank Hector Kobbakadu Agrarian Institute and SIDA for allowing us to park our vehicle. And another thing, and especially our media partners, ITN, Rupawahini, Theranos, Sri Lanka Broadcasting Corporation, and Daily Feed. You may have seen, throughout this week, they have given enough slots for us to publicize this event. Thank you. Also, I can't forget our IESL CEO and the staff. Unfortunately, I don't have time to tell their names. You can see a lot of people in my left-hand side, and also some people who are at the back rows, and some others are in the members' lounge and the canteen. They are doing a lot to arrange your foods as well for the next event. Thank you very much. Thank you very much, CEO. And next, at last, not least, those who have participated to this event physically and online. Because unless you are here, we cannot do this event. Thank you very much. I think I missed one party. Let me tell that. A lot of past presidents who guided me. They gave individual advices to me. I can see a lot of past presidents today. Mr. BRO was there until a few minutes before. Thank you very much, sir, for your kind guidance. If I missed anyone, please forgive me. Good night. Have a pleasant evening. And please don't forget to go and have the dinner. It's ready on both canteen side and the members' lodge. Good night.
Thank you, Engineer Mangal De Silva. Ladies and gentlemen, as we now conclude tonight's celebration of World Engineering 2026, we leave with a clear and hopeful vision of smarter and more sustainable of Sri Lanka. And thank you all for being part of this milestone at Institution of Engineers Sri Lanka.
And we are Harsha and Sudeepa from IESL Toastmasters Club.